In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows.
Hola, amigos. Hello and welcome to Aether Cosmology Twitter community event, our annual Friday community shindig and get together. I forgot to pull the chat windows up. Give me a second. Get you guys on the screen here. There's the boys. Join the panel here in a second. All right, Shane up there. And this one, we didn't do Rumble tonight. Good. All right, let's tap in with the boys here.
How many coincidences there are going to be before you accept, hey, maybe there's something there. But I don't know if that answered your question, MF.
Yo, Uvalde, you back, man?
Shout out to Shane.
Dude, is that big Uvalde in the house?
Yeah, he had to step away for about 15, 20 minutes. He'll be back.
Oh, dude, that's my boy.
I sent Shane a mic, but I don't know if he's going to take it or not.
Just talking some young gravity.
Oh, little G or big G? Are you talking potential or acceleration?
A little bit of
I
all
don't
of it,
know.
bro.
In
He's
space-time
asking us-
curvature, are you conserving it? Is it in a field? Are we describing it with differential geometry in
Bro,
the
we're
form of a
asking why the
manifold? Like, what are we
gravitation-
doing?
We're asking why the gravitational constant is what it is, and motherfuckers be like, yo, I don't know, man. What's your proof? What's your
It's like, dude, when I hang these balls together on a stick, they oscillate. And when I measure the deviation within a certain threshold of that frequency, I say that I measured the big G. When it's outside of that frequency, I say my apparatus is experiencing an anomaly.
Hey, when you hand balls on those apparatus, sometimes it's done with students around in the room. Don't those students have mass? How come that doesn't trip off the experiment?
Oh, dude, because the real trick for real, like you want to know the real trick? So if gravity's like a dynamic system, right? When your boy, for real, your boy Cavendish, when he was in the shed looking through his telescope because of the sensitivity of the gravitational potential from even his own body would affect the measurements, right? He didn't even, do you think your boy gave any consideration to the position of the planetary bodies and their gravitational influence on them? Moon, Jupiter, Sun, the biggest influences that would affect these measurements. But my boy was so concerned with his body weight that he was like, "Yo, I gotta observe this through the shed with the telescope." Now,
Damn, he had to go in the shed, but the students that replicate this experiment, they could be all in the room and no problem. What the heck?
Right. Because here's the trick, big dog. You hang two balls on a torsion balance beam, they're gonna oscillate, my dude. They're going to have a little periodicity to them. So when they analyze that, right, when they get that little small deviation, like for whatever reason it happens, electrostatic, God changed Coke to Pepsi, who knows, right? But they do this thing, but they have this like little threshold. And when they measure it within that threshold, they're like, look, we found big G.
There's gravity right there because we took two big balls, put them on the end of a small string, and somehow, some way they started to move. We couldn't figure out, could be the tension of the bar or anything like that. Nah, whatever.
I thought he was weighing the Earth.
Yeah, so the result of the force to produce the deviation angle, right? You would that's how they backwards derive what the gravitational potential would be between the two. That's how they get that big G.
You know what the weight of the
And
Earth
then
is?
and consequently, that's how they get big M for the mass of the Earth, which then they could apply to the sun, and then backwards derive what the mass of the sun would be, and then outward they could do everything with respect to the mass of the sun just through a little algebraic shuffle.
You know what the weight of the Earth is?
Off the top of the dome.
It is officially 6.66 sextillion tons. 6.666. I can't even say that word. Sextillion tons. There's a tongue twister. Got that off of Cavendish, huh?
Yeah. And then apparently they had to adjust like the density of the Earth based off of that because they can reverse engineer like what the density would be to create that weight. Right. And then so they had this whole thing where they had to basically, add in the old rotating iron core to make up the weight difference. Like it gets crazy when they're like just what they did with that one Cavendish measurement. They were like, all right, dude, spinning core, anyone?
We got it all right here, man, in this one special room. Figured it out. I mean,
Damn, it's amazing how much stuff you can find with a torsion ball and torsion bar and some
Dude,
balls.
Yeah, you take some balls and a torsion beam and a telescope, dude. You can weigh the planet.
You can do anything.
What do you mean in the shed, Alan?
Oh, so my boy had a shed, right? Because he didn't want the apparatus to be disturbed by anyone, and to control the air and all that kind of stuff or whatever. So he had it in a shed, and then so the story goes is that when he was making his observations, he would go to a telescope that he had like peering through a window in the shed or something like that because, gravity.
Was there trees and stuff around the shed? I'm just trying to figure out all this.
Great question. Your boy lived on a giant manor, and I don't think there were any trees nearby per se. At least not in the hand-drawn illustration that definitely happened, that's definitely depicting a real event that happened. Didn't show us any trees on the side.
I appreciate that.
Shout out to Matt, B. Esticles, Dr. Galactics. MF, you could have stayed up here. There's plenty of room. Stone, the rest of the gang, anybody I missed, share the space. Hey, well, this is what I want to ask. I was half listening to was it Friday Space? And supposedly there's something new out off the presses, and Ken and Conspiracy and Nick, Brian explained a little bit about it. Is there some new celestial observations with refraction that necessitates a flat baseline? Can you elaborate if you know what Pizio was talking about?
The refraction coefficient correction, where they just do repetitive curve correction on flat baseline measurements. Is that what you mean?
Yeah.
Ken that is what he means. Yep.
Yeah,
like that,
Ken did a good job explaining. Is there anything else that where are you guys doing a presentation on it or something soon on?
So currently building it. It should be the presentation for Monday. It's titled, what is it titled? Flat Earth and the 24-hour sun, where is your model? So we're going to be going over how to make a model, how to make a map, and what it means to use the apparent positions of the bodies in the sky to make a map and a model.
But yeah, no, what happened was Jesse, the Path of Light, stepped up for the globe and tried to battle the celestial theodolite with all of his might and wit and glory, and he made a GeoGebra model which employed heavy refraction on both ends. So, the only way to beat the celestial theodolite is to maliciously and surreptitiously do refraction at every which point, from the house to the observer, from the star to the mountain, from every which way. And lo and behold, that's what he did. But he did so with such a formula that we had to look into it, because it was applicable only below 15 degrees of the horizon, I think. And it was just this, like, if you were to plot like a best fit line and do like a y equals function on it, it would be like the best fit curve to make this flat baseline curve as hard as you can at this rate, based on the radius of the Earth that we know. And what we'll do is we'll take every measurement at every latitude and we'll apply whatever the specific corrective quote curve calculation formula is, and those come out in the math as constant. So the first thing that we saw was glaring weird ass constants, just like, you know, variable plus 293.7, and you're like, what the hell is that 293? Like, what does that mean? Where does it come from, and why is it employed so well? So we had to look into that, and it turns out that this corrective celestial correction, right, because it's not refraction, it's all it's doing is calculating the globe literally right back into your flat baseline elevations, but it does so like blatantly and with what you would call a brute force effect, right? It just takes that flat and forces it to be curved with these giant glaring constants. So that's how Jesse has defeated the celestial theodolite, with the mathematical model implying refraction at both ends, which is, you know, retarded.
Oh, and quick note on that, right? The actual situation at hand is that we're using the raw plane trig for our predictions, and we're using the geometric position of the star, so-called, right? Like the actual geometric position, not the one that you apparently see, because we only see the apparent. We're using what's logged in the in their catalog as like the true position, right? So when that true position intersects at those angles to create that's only ever happened on our model, right? So the adding celestial refraction to the apparent position and making it about something it's not, that's not even analyzing the celestial theodolite, right? Like that's a completely different hypothesis.
That's dodging the argument entirely and making it about something else.
Like let's not forget about the actual geometric argument here. Like the celestial corrections, right? The entire purpose of the celestial theodolite is to show that, like, what the discrepancy is with those. They make up the difference in the flat baseline, and they only apply the correction correctly with respect to a flat baseline. Because if you try to use that simulator using the globe derived angle, it doesn't work. Celestial refraction only works with the angle that starts with a flat baseline. That in and of itself is game over. And then so check this out. The way that they model it out, like Shane already touched on, they start with the globe, right? Their input is the globe radius. And then they start from, like, imagine you're like a little marble, like you're just on a little tiny ball with no atmosphere. And then they have math functions to basically build out a gradient for every distance radially outward from that globe. And then as you get out to 20 kilometers away, that table describes like what's going on within like the 10 kilometers of that 3959 radius, right? Outward. So for any elevation at any lattie, like Shane was saying, it will conform to that sphere. And then they've concluded that based off of the correction where they've changed where the apparent position is now, right, to be where it really is, they've, concluded that the Earth's a globe off of that. That's like multiple levels of insanity, dude. Imagine if we showed up and was like, yo, we got all these flat measurements, and they were like, oh, word, you got flatties? What do you got?
The globe out
and we had, dude, and we had coefficients for uniquely for every measurement at different times a day that squared out the globe, dude. Like, it is just like, hey, this is our proof. Where's your measurements at? They would laugh us.
Math. Yeah.
Dude, they would laugh at us so hard.
That's the baseline. So, like, as you were saying, dude, they start with globe, they calculate globe, and then they finish with globe, and they go, baha, concluded globe.
Real quick. Hey, I just wanted to say, yes, we would. As a globe, we absolutely would laugh at you at your numbers. And that's why I'm in this space, because nobody questions what's the narrative, what the current narrative is. So
cool.
I do appreciate you guys' input on this stuff.
Nice. Yeah, dude, you should check out those celestial corrections, because they're not derived from temperature and pressure, right? They're literally designed to fit a curve to make the globe the globe. Because there's terrestrial refraction that they accommodate for, which is like a real thing, temperature and pressure. But then what they do is they'll take some meteorological data from a particular night, right? So they'll use that as a snapshot, and then they have adjustable variables in the math that they can use to adjust that snapshot that they're putting in to, you know, form fit any quote unquote anomalies or whatever, right? So like it's preposterous. It's not even like you couldn't even test it. It's like theoretical calculations based off of assuming the atmosphere is a smooth homogeneous gradient that goes out to infinity. Well, you know, 20 kilometers essentially, and then there's no dynamics to it. It's just a smooth homogeneous gradient for funsies. Like that's what they calculated. They calculated a smooth ball and then concluded that we live on a smooth ball.
Well, they also provided the infrastructure.
Dude, how crazy is that?
For you to do your calculations in.
They made a smooth symmetrical ball gradient and was like, guys, you're never going to believe where we live when we look at the stars. Smooth symmetrical ball.
It's not the stars curving at the exact same rate. It's actually the ground doing it, but you'll never see it and can't measure it.
Well, what if we been a stickler and say, hey, wait a minute, those constants are the same that you're applying for that transformation, but you specifically said it's not spherical, it's oblate. So where does the oblateness come in? What do you think they'll say?
Not a thing, dog. So all of that would be wrapped up within it. Like it's already incorporated in it. So the oblateness came like hella before. So with the almanac, the history of the almanac, there was like a quote unquote corrections to it or whatever. And so from the historical narrative of the supplement to the almanac in the ephemeris and the American almanac and all that, they say basically what they did is they went around and took zenith measurements of stars, assuming, and the way that they calculate it out is they assume what's called a geocentric coordinate. And what that means is they're an observer standing at the center of the Earth looking directly up, and they're assuming no refraction because you're just looking up at your zenith, so there's the least amount. So the way that they do this is they were like, you know, verifying the quote unquote positions of the stars. So they would go underneath them and they would take zenith measurements of them. And then any deviations, they were just like, oh, well, that must be because the Earth's actually like, you know, not a perfect sphere. It's a little oblate. So they just have like additional corrections built into that. The celestial corrections already like incorporate everything. It's like two separate models that intersect to make a big model.
Yeah,
Nice,
that's
got it.
What do you think about all that, Uvalde?
Dude, I know Uvalde's thought deeply about it because we've discussed this before. What up, big Uvalde?
That's combining the geoidal model for the gravitational potential so they can know where down is when they're trying to get vertical vectors and tangents, right? And then you have the ellipsoidal model, which is how the WGS84 works, which is the baseline for, you know, X, Y, and Z of ECF coordinates, and all the other things that they try to say measure curvature actually just reference that ellipsoidal model.
Apologies, I wasn't really listening. I was multitasking, so I'm sorry. I sound like a complete dick right now, but I apologize.
No worries, lad. I know you're a busy man.
But I would like, if it's okay, and I'm not derailing any thing you guys were talking about before, because like I said, I've been multitasking. Would like to find out what the flat Earth reasoning is between why things weigh more at lower elevation, and why, if it's just electrostatics, we can't test for that.
You didn't hear Ken go over all that?
No, man. I've been working and multitasking, and so no, I have not. I apologize again. So sorry, guys.
You want to repeat what you said, Ken?
I thought I said everything before he left.
Yeah, it was definitely before he left. We were talking to you.
Yeah.
But that's all right. That's all right.
I kind of want to hear Ken go through it again. I kind of forgot it. What's the answer, Ken?
So, for
latitude dependent
on why
measurement
things
of
are lighter, you know, up high. I on that particular question, I told him I don't know. I have no idea. We were discussing he was talking about gravity,
Electrostatics. Yeah.
and so I told him, well, I have a theory on gravity, where the electrostatic gradient provides a bias, a direction for a force to act, and that force would be weight. All matter has weight inherently, uh, in my way of thinking, and so that's why things fall down. But specifically to the question, why does it weigh less on top of a mountain than it does at sea level? I told him I didn't know. I've never done that. I couldn't begin to imagine.
I mean, I still don't know what the weight difference is. What are we talking?
Well, yeah.
So the globe model has an explanation that comports with what the globe model says. Flat Earth doesn't sound like they can answer that, which is why scrutiny is important, right? Like you can say you believe.
What if I said we had bendy, warpy space time? And
I mean, I really haven't heard even what the difference of weight here is, or that this is an actual thing.
Yeah, well, see, it's one of those things that you can test, and there's even documentaries on like Prime, for example, that where these students, they will measure the weight of something at higher elevation versus lower elevation, and
does it fall off at R squared?
But I don't know.
Do you know?
Lower elevation things weigh more because they're closer to the center of gravity.
Do you know if the difference between the two measurements is a difference that would fall off over R squared, or is it like a linear?
I don't know.
We'd have to look at that because
objects weigh less at higher elevations, and it's been confirmed. It's been demonstrated at multiple times. Like there's no dispute about it.
It never met her, dog. You'd have to send me some stuff to look at.
Right.
Yeah, I can do that.
Well, like even entertain it, we have to see the measurement. We have to see the discrepancy from height, and then we can figure out based on if it's a metric of the square up of the fall, right? We can see which formula they're using to calculate it, because of course you got little g being an aspect in there. We just switch that out with little a, right? Because we do function.
I mean, it could be. I mean, he was using an anvil before as his example. I mean, what's the weight difference here? It can't be like pounds, right? What are we talking, like a skosh?
Well, I'm not sure if it really matters what the weight difference is. The fact that
it matters significantly, because if you're at the center of gravity on a ball, the gravitational potential falls off at R squared. So you're not going to have a linear discrepancy in the weight difference. That's why I asked about it, is because it's going to be geometrically different.
There's a difference at all.
No. 1 second. No. Well, hold on. That's totally here's where you're wrong, right? The geometry of R squared is dictated for a sphere radially outward, right? A linear progression is not spherical geometry. So that's why it's extremely important to know the difference between the two. Otherwise, you could be looking at a measurement and draw the wrong conclusion based off of, not knowing the difference between R squared and just like a linear function.
Which would be mutually exclusive in this case.
It's all about the gradient, bro.
Okay, I see what you're saying, but that doesn't change the fact that there's a difference, and that difference is what is so important here.
It changes it. Hold on a second. It changes it drastically, right? Because what's asserted is constants through big G and big M, through Cavendish and all of that. So if those things don't have any physical meaning, then they're just values that don't describe the actual mechanism or why there's latitude and elevation dependent differences. Right, that's the big discrepancy here, because there's other things we can go to analyze big G rather than something that has a measured differential at elevation that may or may not be comporting to R squared. We have other ways to look at big G, such as like Michelson-Morley, right? Is there a force produced between the Earth and the Sun that's creating 30 kilometers a second? Like we can look at all kinds of aspects of big G to analyze whether or not it's true, rather than just one measurement that isn't mutually exclusive to either model.
And to your own point that you made earlier, you said the terms are important, and it's not just a difference. Your model has, as Alan put, mathematical musts that must take place, right? F equals big G.
Entailments.
Right, exactly. There's necessarily entailment. So if it's proportional to the product of their masses and inversely proportional to the square of the distance between them, that means something. There's values that it must comport to. So it's not just, oh, it's different.
And again, like, can you prove this is like an effect of whatever you think gravity is? I guess would be my next question.
Yeah,
wouldn't matter. Wouldn't matter.
It matters because it aligns with exactly what the globe model says.
What do you mean? What do you mean it aligns exactly?
So hold on, you just got a little sidetrack there. One second. We just hold on.
Because closer to the center of gravity.
Listen, we just went over how, like, you don't even know if it aligns. You don't know what it's following. You don't know what the weight difference is. So you don't know, right? So like let's back it up a minute. Now, on top of that, right, the cause, right? If you just have a measurement, right, that doesn't tell us what the cause is, right? Even if you have a mathematical relationship, doesn't necessarily mean that you know the cause. That's how a lot of people end up with, we could take Kepler and Big G with that.
But it fits in line with what we think. So I mean, you're right. We don't know what the cause is, but according to this theory, this sure does seem to fit.
Well, you keep saying that, but you haven't even substantiated the gradient in which it falls off at. So we should come back to this.
What do you mean? What do you mean? No. Elaborate what you mean by that.
Okay, so did you understand what Xavier said about the significance of inversely proportional to the distance and the falling off at r squared and all of that?
No, I don't. I think you guys are throwing out all kinds of words without really.
I got you. No worries.
Word salad.
No worries. I'll try and help you. So check it out. If you live on a sphere and the gravity works in the way that they say it does, being inversely proportional to the distance away.
Okay, listen. I'm sorry. With all respect to who's talking, listen. Yeah. If I keep getting fucking muted, I'm fucking done. Okay.
Let him explain it real quick to you. He'll give you.
Oh, I'm sorry.
I'm okay with that, but there's going to be a little bit of back and forth, and I am definitely okay to hear what has to be said. But if I'm going to keep getting fucking muted, I don't think then I'm fucking done.
Fair enough. No. Fair enough. I think it's all good. I think it just means when I'm just like telling him to hold on a second. Now you're good. Okay. So if you want to talk or whatever, just feel free to chime in if you have a question or something. But so suppose we live. So suppose we live on a sphere, right? The gravity, the way that it's going to be stronger at the surface, and then the way that it's going to not be stronger as you get further away, that has to follow a certain mathematical relationship, which is described by the function r squared. So when you get away, so as you get further away from it, right, it's going to be a squared relationship. It's not going to be linear, meaning it's not going to be like 10, 20, 30, 40. It's going to be like 10, 35, 70, 95, something like that. It's not going to be a linear progression. It has to follow a certain relationship mathematically. So I was asking you if you knew that what the differences were at the where the measurements were made, because then if the difference follows an r squared relationship, that would be good evidence. If it's just different, then that doesn't tell us anything, unique about the measurement.
Right. Happy to. Go ahead, Yuval.
I don't have the details, but I do know that because it is easily confirmed that that's what we observe, that it aligns with a global Earth and not a flat one. But I don't know the specific details with this r squared thing and this and that, but I can take an object, an anvil or a bowling ball or whatever, up to the top of a mountain, and it will weigh less than if I weigh it at sea level.
So what if I told you? Much less. What if I told you that's because there's more unicorn parts up there, right? How how have you proven it's mass attracting mass, right?
It's not proving it, but it's evidence that supports it.
Well, I think we've reached the maximum amount of conclusion on the gravitational potential at elevation.
Yeah, I
Well,
don't
so
want you to repeat that again, please.
Baseless
Jeez.
assertion upon baseless assertion by conclusion. I think that's
Conjecture
what it means.
without data. That's all it
Yeah.
is.
So I was wondering if anyone out there could explain eclipses. That seems to be a point of contention in why flat earthers can't
Explaining them. Okay, so check this out. I'm going to quote from my boy Nicholas Copernicus before Shane explains where they're going to be. One second.
Explain how the predictions could work on a flat Earth. How could it be?
Yep.
Huh.
Flat earthers can't predict eclipses, man. It can only happen on a globular mess, and NASA.
Why did that happen?
Flat Earth.
And what about?
No, it's not a matter of it can only happen. It's a matter of we use the information that we have, and because of that, we are able to predict an eclipse.
Do you know where you got the information from?
All right.
It doesn't really matter if the information is correct.
It doesn't
Of course
Time
it
out,
matters,
time out.
bro.
It really does matter. And so,
If the information is correct, why does it matter?
so how do you know it's correct if you don't even know where it's coming from?
All right,
Stone
boys.
just asked
All
me
right.
where it's coming
Well,
from.
because you can be in the path of a total solar eclipse, and and there's also a narrow band for where it's going to be, and if you're there, you can confirm that.
I see it, therefore glob. Gotcha.
Well, well, yeah. I mean, it's all evidence that supports things. Yeah.
How does something moving in front of something else in front of the sky prove you're on a globe?
It doesn't prove things. It supports things. It supports the fact that we are on a globe because we were able to make an accurate prediction.
You have an explanation, we have an explanation, right? And it's solely based on observation. You standing on the ground, you looking up and taking into account what's taking place, and then you applying your theory and what you think is taking place based on a framework you work within. It doesn't mean that your framework is correct. It's just you have an explanation within your framework. That is all.
Yeah. The word you're looking
I tell
for
you
is
what,
not
if
mutually exclusive. It's not mutually exclusive, bro.
If there's a flat earther that can make an accurate prediction as to when the next eclipse will be and where it's going
to Wait. Givaldi, do you want to bet money? Do you want to put money on it?
He just said we figured it out, and then when Stone asked him, okay, where's the information? He said it doesn't even matter if it's correct, right? So like
I know.
Just appeal.
But hold on. Do you want to bet money on it, Uvaldi? That flat earthers can make a prediction about when an eclipse is going to happen?
Shane has already won 10 grand.
Hey.
Why not some of your money?
Well,
too?
I already explained it to him earlier, Beasticles. He must have forgot. But this is the gentleman I was mentioning earlier who won the bet.
How would you not use what the other predictions already say? I mean, that would be the question. Why? Because a flat earther can can look it up and see what NASA says, go with what NASA says, and then all of a sudden you win money.
So check it out. We went to go. I don't know if Shane's still there. Are you there, Shane?
Oh, yeah.
This is like your bread and butter. Okay.
He's just biding his time.
Go ahead, Shane. Go ahead. Go ahead.
Go ahead, dude. You got it. I'd like to see you do it.
All right. So the thing is we went to NASA's website, right, to see what the boys were cooking up because we had heard that NASA was making all these predictions, right? And you'll never guess what NASA, like how they predict things. They actually don't predict anything. They give a huge disclaimer that says we predict absolutely nothing. Everything predicted here comes from our boy Fred Espenak. Who's Fred Espenak, you ask? Fred Espenak is a gentleman who went around the world and collected different what are they called? Like celestial like eclipse catalogs, basically, like whatever they call their star catalog stuff. And then he took those and made data tables out of them and what happens with the eclipses is that it's just a periodicity thing, right? They happen in a cycle. So once you know part of the cycle, you can mathematically extrapolate the rest of it out and where they're going to be, because all of that is just a function of the same, like the period, like the repeating cycle. So that's all it's ever been, and that's all it ever is. And then there's a new thing that came out where they're like, we're going to introduce basically solar system dynamics. We're going to hit up your boy Big G and Newtonian dynamics and do the heliocentric prediction for that book, and then it changes the predictions where they don't do any of that and they just do kinematics like Shane did to win that 10 grand. And the difference between the two is like 0.001%. So that there's actually no change between adding in Newtonian dynamics to the solar system.
Yep. Shane won $10,000, bro. Mord
But like
filled and Mord won.
the point before I even took the bet was that nobody predicts eclipses. They're all based on cycles, as we were trying to say and lay out, right? And even NASA accredits the person who stole all the cycles and put them all together for everyone to download, and then printed all his nice books and made his atlases. That's Fred Espinat, tells them on NASA's site, right? So like there's no math. You're not making a prediction with a dynamic cause in physics. You're not doing the math of the celestial body to say, all right, here's what it's going to be. That's not how it works. They use ancient cycles.
It's just cycles.
So it's based on lunar periodicities. There's 3 parts of the lunar cycle that they use: the synodic month, the anomalistic month, and the draconic month. And they just mean different times when the moon goes from, say, new moon to new moon in its phase, or like perigee to perigee in its elliptical point over the flat Earth. Or you can do the draconic month, which is node to node, right? So it passes ascending and descending nodes. It's time when it intersects the sun's ecliptic over us. Super easy. When those align, you get to a lunar cycle. So they actually all contain 6,585 days or so. And when that lines up, it's like 18 years, 10 months, 11 days, and 8 hours. And that 8 hours puts an offset that has it repeat at the same place, but 30 degrees offset, right? So a third of the way around the world. And then that eclipse will repeat 3 times. And then that's how they build the Saros cycle, which is that repeating ever repeating cycle over and over again over thousands of years. How it actually works, though, is it deviates between lunar and solar cycles, right? I mean, lunar and solar eclipses, rather. It doesn't go all lunar and then all solar. That's how the data that Fred put out through NASA goes. He has 2 archives, one only solar, one only lunar. If you put them together, you actually get the real cycle, and that's how we're able to predict eclipses and say when the next one's going to be, which is actually what the data shows. If you go through the data, you have things like sun azimuth, elevation, time of eclipse, things like that. It's all just empirical observations of the sun. You have things like solar and lunar disk size. What's that? The size at which the sun and the moon appear to be, right? 0.53 degrees based on the angular size formula. They do some calculations based on distances. So they have some wild fluctuations in the math. All that's used is observations of geocentric celestial bodies put on as ancient cycles, which are based on the 3 lunar periodicities, which ever repeat. If you put the solar and lunar together, you get like a great astronomical year, which is 651 years. And once that cycle is done, that repeats in ad infinitum, and then they repeat over and over again. The time when that's 8 hours offset, creating the eclipse 1/3 of the way around the world, it's actually called the exogemelous cycle, which is a really hard word to say, but that's when it appears at 3 times of that, and it appears at the same spot it did the last time. So an eclipse will occur 1/3 of the way around the world, 1/3 of the way around the world, 1/3 of the way around the world, and then that'll happen exactly at the same time. So putting all that together, you have basic ancient observations put into ancient devices. You have, let's say, the astrolabe, which is a version of the planosphere, which is a stereographic projection of the 3D hemisphere onto a planar surface, which is exactly how you get all the basis of maps today. But yeah, what we did for the eclipse prediction was actually a solar eclipse, which is the path prediction, because of course it comes with the caveat, oh, you can't predict the path of a solar eclipse. So what you do there is you drive a fundamental plane through the axis of the observer, and you do some math based on, of course, geocentric observations, and then you get what's called Besselian elements, which is just basic variables and functions, and you have like a squared function and a cube function, and that will determine whether it's curved or zigzagged, and then you have like an x and a y component for above and below the horizon. So it's pretty much just an XYZ coordinate system projection that you get with a flat plane through the observer. And then that you have to map, of course, on the graticule, which is what I've always said is the only heliocentric part of it is the map you have to plot it on. So there you go.
And to be clear, that 8-hour third of a day offset is actually 120 degrees, of course. Right.
Sorry, thank you. That's right. They're the way around the
Rob,
right.
just keeping it straight.
What's everyone's
So you
favorite
taking
eclipse
notes?
cycle?
Hey, Uvalde, you taking notes there, buddy? What was really significant there was that over hundreds of years, literally hundreds of years to a single cycle, there
I
is
love
a
that topic
series.
because people make bold, assertive claims about which they know very little, right? They're like, all the heliocentric model predicts eclipses. I've heard that so often. If you could name one aspect in the data that's actually exclusive to that, I'd be astounded. If you could look at any ephemeris that isn't geocentric, which is based on every single ephemeris is geocentric, except for the two that they base the solar system model on, right? So every ephemeris, every observation, it's all geocentric. Now, when you get to eclipse catalogs, you have Fred Espinac didn't even make it by himself, right? He stole it from a French guy who put it out in 1894, which is actually more eclipses than what he had. The only thing that Fred really does is sell atlas maps, I think. He mapped them out on the Graticule really well, and he put them all together, and he made them all on the sphere. But he also took his predictions from older books who took their predictions from older books who took their predictions from the older societies, right? That's
I'm starting to see a pattern.
These observations have always been around, and once you tabulate the actual repetition
Now,
of the cycle,
I actually thought I heard one of you guys talking about this.
Because you know you've seen the cycle, right?
Yeah, I thought I heard one of you guys talking about this, and whoever did it used like 3 different
there is no, math
math
calculation.
Hold on.
There's no
So Shane,
problem being
Shane,
solved.
do you hear Brian?
I don't think Shane can hear me.
In 3D space, so.
Oh, Shane, can you hear
I
us?
don't think Shane can hear me either. Shane, you can't hear me, can you?
No,
I don't think Shane can hear anybody.
Crap.
Oh,
Yo, Shane, drop down. We'll bring you back.
You got
So
Twittered.
Uvalde, while he's doing that,
I
what you
think-
need to understand here is Uvalde, over a span of hundreds of years, this cycle he keeps talking about is developed from inclusively what they call the Saros cycle, S-A-R-O-S. But what's important there is that the series, in order in which all of these eclipses occur over hundreds of years, happens cyclically in the same series order over and over, hundreds of years, end on end on end. It's not about can you make a prediction. It's merely a question of observing where in the cycle we currently are.
And didn't they
it's
also do
post-diction.
that? Didn't they do that to go backwards and get it to where it didn't even have any movement?
Yeah, it's nothing but post-diction now. It's not prediction.
Oh yeah, but we're flying through space millions of miles per hour, but we have
At these wacky velocities with some 4 types of orbital precession at varying scales, yet still these orientations are exactly as they have been for centuries.
Oh, my bad, Stone. Oh, I'm bad with the emoji button. My bad, guys.
Dude, if you mute the room one more time.
I was just saying for centuries on end there. You know what I mean?
And all I had my hand up for earlier was it astounds me how these people are so assertive that their model has it all figured out. And then when you hold their feet to the fire, ask them for some information or data, they never come up with it. And then we just hear Shane rattling it off like Machine Gun Kelly. And it's just like, all right, I guess we're moving on to the next topic. Like, what do you got? Satellites? I don't know. Man, they make calendars. They put everything on there. They do this for religious purposes and such, and it to think that you're doing this while skirting through the universe at 500,000 miles per hour is just insane. Versus, they're just going over your head in a certain pattern, and once you recognize it, you can predict it because it happens every time.
Dude, speaking of certain pattern, check out what my boy Nicholas Copernicus said in 1543. But since for the same movement varying hypothesis, we are proposing from time to time, it'll be either eccentricity or elliptic, or epicycle. So basically, either the Earth's moving or the Earth's stationary and the things are moving around us in circles, which creates epicycles, or the eccentricity would be ellipses with the Earth moving. For the movement of the sun, the astronomer prefers to take which is the easiest to grasp. Many philosophers demand the probability instead, but neither of them will grasp anything certain handed on unless it has been divinely revealed for them. Therefore, let us permit this new hypothesis, because everyone was freaking out that he was proposing that the Earth is in motion, but he's like, relax, boys, like nobody cares. It's just conceptual models for funsies to calculate. So he says, therefore, let us permit these new hypotheses to make public appearance among the old ones, which are themselves no more probable, especially since they are wonderful and easy to bring with them the vast stored of learned observations, so just however it's easiest to teach it. And as far as the hypothesis goes, let no one expect anything in the way certain of astronomy, since astronomy can offer us nothing certain, lest if anyone take it as true, which has been constructed for another use, he will go away from this discipline a bigger fool than when he came to it. Farewell.
So he proposed it and dismissed it at the same time.
Is proposing it and saying like, don't freak out, lads, because I guess, you know, it was like, you know, against church doctrine to suggest that the earth was moving. And he was just saying like, guys, it's a conceptual model. It's just the math works. It's fine. It's the same, whichever one we prefer. You can do epicycles or eccentricity, which is the elliptical orbits. And then check this out, dude. So not only can you do circles, you can do ellipses. Did you guys know that you can do straight lines to describe orbits? I bet you're wondering, what? How does that work? That's a straight line. We can clearly see him doing circles around us. Ooh, my boy. Have you met my friend Absolute Differential Calculus, which describes curvature within a manifold?
I think I hear the term curvilinear coming up.
Yes, sir.
I knew it.
so they can describe mathematically for, you know, whatever they need to, the paths of the planets. It doesn't matter, guys. The math that describes the perihelion precession of Mercury says that the sun is stationary, non-rotating, has no charge potential, no additional factors or dynamics to it that would give it like any extra mass or curved space in any sort of way, in addition to what they're using for the exact amount to conserve, to turn into a gravitational field, to bend space-time, to cause the deflection, right? They're assuming all of that. And it that's not what the sun is, but the math works and everyone thinks that that's true or whatever. Like, they don't care. It can be whatever, as long as the math works. That was Copernicus's point in, you know, the 1500s. And it's still true to this day. It's just that they got hella carried away with Kepler and Newton.
Yeah, I love Kepler and Newton. I love talking about the historicity there. Yeah, I think that I'm back. Did our globe lad have anything to say about eclipses? I think I lost all
So you feeling pretty good about eclipses still there, Uvalde? You think it only is some globular mess thing going on there?
A globy sourced truth.
You're starting to see that they don't use any globe math, and it's basically doing the same thing over and over again.
Got any more brain busters over there?
Although I do like Uvalde as a respectful glober.
Yeah, he's been
awesome.
He's been pretty cool all day long, man. I guess he's pissed off at conspiracy though. Keeps on muting him, I guess. Bastard.
Yeah, gotta fix his mic.
Emotes, bro. It's nonstop.
Yeah, I even caught a little mute spatter there too.
Oh my God, Shane, stop. Stop.
Look, I can do it without crashing anything. I don't know why you guys haven't.
Can you hear us?
Of course.
Okay. All right. You couldn't hear Brian earlier.
Nope. What happened was I kicked out my headphones. I couldn't hear anyone, and then thought that I broke everything.
Nice. Classic Shane.
Brian,
it's not connected. Okay.
You brought up something about you were trying to ask Shane a question at the end of his monologue.
What was I trying to ask you? Remember?
Fuck if I know, dude.
Damn it. Well, I was thinking that. I thought you guys did a presentation on that or something like that. But didn't that go back to like 6,000 years to where it wasn't moving at all?
Yeah, my presentation used the Eclipse chronometer. It uses Dimbleby, which is like a professional chronologist, which apparently was a fantastic position 100 years ago, and now nobody gives a shit. But he compiled something called the Eclipse chronometer, and he used 5 lines of astronomical time. So he lined up planetary transits, which he used the same sort of cyclical and pattern, and then he used that in conjunction with the solar cycle, in conjunction with the lunar cycle and then using the eclipse chronometer along with times prescribed in the Bible. And once you understand that when the lunar and solar eclipses, when put together, form like a great cycle, that eclipse that just repeats in perpetuity, it's 649 or 651 years, depending on how you count it. But once you understand that, and then that just repeats, there's only been like 8 of those, or no, not even. the total amount of years that you get that the sky has been in motion and repeating the cycle, if everything started on the day of creation, was like 6,020. This would be year 6,020, I think. Just aligns with old school Bibles and all that stuff.
Dimbleby, bro. I still haven't even touched the book you sent me. It's
Dude, he wrote, apparently, so he wrote like 6 books, and the other one was a complete chronology of the world according to the Bible, and then he did this other chronology one. It's such a, if you read like the pamphlet, it's like the the Reader's Group Digest version of all the compliments he gets from all the other writers, and they're just remarkably glowing at what an innovative like way to approach and like how meticulous and accurate all of his stuff was. He was known from the Royal Society. He was known by all the lads, right? I think he mentions George Airy in there, Alan. Apparently all the boys knew each other back in the 1870s, right? So,
oh, I bet it was a pretty tight group.
Right?
Yeah.
And everybody else is illiterate. You know what I mean?
Looks like Chris has his hand up. Did you have a question, bro?
Yes. Yeah, and I apologize if I drop out. I'm up in like northern Arizona, so I got kind of bad service. I'll make it quick. I've actually talked to Brian about this before, and it's just that we have an ancient understanding of eclipses that they are not eclipses of like the cycle of the seasons, and we have essentially these equinox periods that even like ancient civilizations were building structures around and using that. And I guess what I would like to ask is there a basic understanding or a basic explanation that you could give me of what the globe model's explanation is for the equinox and that kind of stuff that only happens twice a year, please?
Anyone want to steel man that? Is
Yeah,
your
and
question
I'm kind
about how do the seasons work on a globe model?
Yeah,
no.
I think what he's asking is
No.
in Mexico, why does the snake go up the stairs in the summertime and down in the wintertime?
What the ruck?
Brian understands what I'm asking, and what I'm asking you guys is can you explain that on a flat Earth model so that I can understand it and just kind of what I'm doing. I'm doing that I'm doing this in good faith. I really want to understand what you guys think.
You guys think the whole world tilted on its axis 23 degrees to make that parallel, right? And we just think the sun's ecliptic is on a tilt that when viewed, to the person creates a 23.5 degree gap, which is called the tropics, right? Which is as the sun precesses from tropic to tropic and goes from line to line there, it produces the analemma, which is 2 points on there would be at the equinox. So the only difference is the perception of how you think the world works. You take the same observation and tilt the whole world at the degree, and we just say, hey, the sun is orbiting over the flat earth at a slight incline, the result of which is that 23.5 degree tilt.
Isn't the analemma actually problematic for the globe because of the size of the northern versus southern? And if so, does somebody want to explain that?
It changes relative to where you're at. So like in the south, it looks like the inverse. So there's no like real discrepancy there. But the real for real discrepancy, dog, you want to know what the real big daddy discrepancy is? You could take your boy interferometer and measure the phase difference when the Earth is parallel and perpendicular to the assumed plane of orbit, and you'll never get 30 kilometers a second in the fringe pattern. Which is so.
That's really interesting. I've never heard that before.
Oh, dude, yeah, you should definitely check out some Mickelson Morley.
Oh yeah, you got to up your MMX game for sure.
Yeah, absolutely. But to answer your question directly, Chris, how do I do this purple pill shit? Like where I could put something in the jumbotron?
All right, so you click on it, and then it pulls up like the main post of the thing, and then just reply to that post. Once you reply to it, in that thread, you can click on the little thing on the right that has like the share thing, and there'll be an additional menu called share to space. Click that, and then it'll pop up in the space.
Okay, let me see if I can figure. So I just click on like the latest, because what I'm going to do is I'm going to link
Yep.
you a video to an old Anon video where he actually conceptualizes what the celestial equator looks like from a certain point of view, where you have it on Stellarium, to where the celestial equator, like to the observer, is like 0 degrees, and then he'll go throughout the entire year, and what the sun will do will make like a sine wave. Like imagine an up and down sine wave, and each of the equinoxes corresponds to what the globe says is a tilt, right? 23.4 degrees. But where they my theory is that they derived it from what they see the sun doing at the celestial equator, and how it just basically makes like a sine wave, right? And they just assume that it's our Earth tilting. But it works in both conceptions, right? You're basically just looking at the sun and seeing it tilt 23.4 degrees off of the celestial equator, and then depending on where you are, like let's say you're at a different latitude, right? You'll still see that exact same kind of sine wave, just in a different position of the sky, of the celestial sphere. So like you'll still see the sun go up, and like if you were to look at it over a whole year, it would still be that same sine wave where it moves between the tropics. All right, let me figure out this purple pill shit.
No, and please don't consider me just a complete moron. Like I'm asking this in good faith because I want to. You don't go to a Protestant to ask about a Catholic, or a Catholic to ask about a Protestant. That's my saying. So
Hey,
there
true
you go.
that, bro. Yeah, I got you, man.
The equinox is what you asked about, right? So it's kind of the same on both models. It's really position predicted by the sun. So when it's exactly between both tropics, right? Twice a year. There you go.
Is everybody quiet, or did conspiracy hit the mute button again?
No,
Right.
Nick took a long white noise silence through everyone, and we were all just waiting.
Yeah,
You know,
I think Uvalde is making a
wondering
sound or something.
I was wondering if Uvalde was gonna say something.
Nah, he's out grabbing a burger or whatever.
Did I do it?
My God, you're clairvoyant. I did grab a burger. You're right.
I used the
I'm getting
force.
something to eat myself, so I feel you, man. I feel you.
Yo, really.
Wait, when you was asking earlier about the object on Mount Everest or whatever weighing less, isn't that just due to pressure? Pressure decreases with altitude, so there's less force being exerted at a higher elevation on that
No,
object.
pressure has no effect on mass. Because that's ambient pressure. It has nothing to do with the density of the mass itself.
Yeah, but that's what's keeping us grounded.
Why wouldn't pressure have anything to do
There's
with
literally
mass?
a pressure gradient.
Because I mean, what pressure is?
Depending upon it.
Because what pressure is?
My apologies.
Because of what pressure is?
Because again, in reality, what would be the mechanism? What's the reason behind an object weighing less, even if it's just by a little bit? Because from what I read, it's a small amount, but it is a measurable amount. So an object its weight does decrease with altitude.
So,
which is evidence for a globe Earth.
No, it's not evidence for a globe Earth, right? That you can't just say it's evidence for a globe Earth.
Well, it's supposed to be electrostatics and density, right? It's supposed to be electrostatics.
Yes, this is why I'm saying it's pressure, because as you gain altitude, the pressure gradient, the measurable pressure gradient that we have, the gases, that pressure decreases with altitude. So that's a less amount of force being applied to the object.
Again, why can't we have mass attracts mass and it be flat too? I mean, I don't know.
Well, because if mass attracts mass and it's flat, then either gravity would have rounded out the flat Earth, or the gravity would be infinite.
It would have rounded out the flat Earth. What does that mean?
Well,
He's conflating cosmological models. He's
that's why the
conflating the
Earth is
globe model
round,
and
because
applying
of
it to
gravity.
flat. No, man, it's round because it's made up. That's just a model they are attributed the physical ground to based on how they measure the sky and map the sky. They map the sky spherically and apply that to the ground.
So you would either have a round Earth or the gravity
No,
would be.
we have a specific way that we observe the sky above us due to the distance
Jesus
and depth
Christ,
within our
man!
field of view.
You guys don't like to let other people talk, do you?
Hey,
Yeah, it's just you're repeating the same talking points, dude.
Well, I
We're still
can,
gonna
can
let
I
him
finish the
his
sentence or no? I mean, are you guys
Marky
just going to drown me out? You tell me.
All right, give him a chance, guys. Go ahead, Uvalde. Tell us how the gravity causes the planets to form the round balls.
Well, yeah. So why you can't have a flat plane and gravity is because gravity would either round the Earth out, or if it's an infinitely flat plane, then the gravity would be infinite. So that is the answer to the question that was just asked, which I tried answering like 7 times, but yeah. So
You're applying the globe framework with what gravity is to the flat Earth. You're just taking flat Earth and saying gravity causes it to look like a globe. That's not our approach.
Dude, I think the observation and measurement of 9.8 meters a second is all this is based on, right? 9.8 meters a second per second downward. That's what you're talking about. However,
and it accelerates too. Yeah, I mean,
not related to big G. It's actually just a kinematic function, right? You can do it with just a function of height and time. You can do h equals 1/2 a times t squared, and that can break down into 9.8 meters a second. Like, say if you use, regular observations, if you drop something from 15 meters and it takes 1.75 seconds, you can use a equals 2 times, say, 15 for the height over 1.75 squared. So it would be 30 over like 3.06, which when you do the math out, lo and behold, 9.8 meters per second. So nowhere was the Earth a sphere, or did I use a fictitious force of mass attracting mass to arrive at an empiric measurement of 9.8 meters per second. That is model independent, right? So to from there assume that actually if this were true, then the dynamic cause we assert baselessly would also be true, and then this nonsense, like this physics would ensue that would wrap the whole world into a sphere, is kind of a giant straw man and a misuse of physics, in my opinion.
Man, you would be very good in the sales industry, because you are very good at bullshitting.
You got the word. Are you accusing him of word salad or what? Did you understand what he was saying?
Oh no, I understood what he was saying. He's completely full of shit. Yeah, which is why I said he would be very good in the sales industry, because he's clearly a professional bullshitter.
Well, what was full of shit that he said?
Yeah, specifically.
The boy, I'm trying to remember it all, because all I remember thinking is, hey, hang the fuck on. All I remember thinking is, oh my god, this is ridiculous. So I'm trying to remember specifically what was said so that I can.
You got it, bro. I believe in you.
Rephrase it. Thank you for the confidence. Shit.
All right. So
I'm driving. I can't remember. I just remember during his talk, I'm going, oh my god, this is ridiculous.
It's all good, bro. It's all good. Just real quick, just as an olive branch. All right. Does anybody in here deny little g?
No.
Dude, I fucking love.
What do you mean by little g? Just gravity? I mean, define little g for me.
Well, this is a very important. Yeah, this is a very important distinction, right? What we're challenging is big G, not little g.
Can you define the differences between the two, please?
Isn't big G like Einsteinian and small g is more Newtonian? Is that correct?
Little g is kinematics, observation, measurements. Big G is dynamics, causal, and prediction, right? So that's the distinction.
So little g is downward acceleration, and what we can observe and measure when an object falls. Big G is what is the cause to that. You would see the effect, little g, the cause is big G.
No one disputes 9.8 meters per second, right? That's why we are able to derive it as a function of height and time. That's the most important part. That's a kinematic equivalence, right? All you need is how high it dropped and how long it took to hit the ground for you to get 9.8 meters per second as a measurement. Nowhere do you need big G or mass of the earth or anything like that. It's A equals 2h over t squared, which is A, the acceleration down, the two times the height over the time it took to fall squared. It's very simple, and that's why I gave it the simple formula. There's many different pairs of data you can use. You can do experiments. It always comes up that way. So we're only disputing the dynamic cause, which is of course back to Cavendish, which is an assertion based on a torsion, which is trying to deduce the mass via the density of the Earth. That's how that comes around as a very
I'm gonna
very
weigh
loose
the
assertion.
Earth. Just insane. Like, Evaldi, do you think that Cavendish's experiment, when his goal, like, was actually possibly, like, how is that possible to actually weigh the Earth, like the entirety of Earth? Like, wouldn't you have to know the entire dimensions of the Earth and every single part of it, all its mass composition, right? Like, nickel weighs different than iron, etc. Like, the list of variables goes on and on. So how are we just gonna let this guy assume the density of Earth?
Are you trying to tell me you don't believe the Earth weighs 6.66 sextillion tons? Beasticles? Is that what are you questioning that? Are you questioning that?
Science denier?
You know what's funny is that value can also be derived using a whole different paradigm in electrostatic forces using Coulomb's law instead of gravitational law, because it was put forth by Spears in a paper doing the exact same thing, and he comes out with G equals, I think, negative 6.68541 times 10 to the negative 11, but his unit equivalence was Coulomb volt meters per kilogram squared. So I mean, they have this whole thing on Cavendish and how they come with the constant that, of course, as Alan always says, has no physical meaning. Because don't forget, when you're using the mass in the gravitational formula, when you're equating gravitational force to centrifugal force, the math drops right out, and you're only doing the same sort of kinematic observation before, which is, of course, why Newton's law is derivable from Kepler's law and how you get, the observation reduced just to the periodicity and the constant. I know that was a lot, but it all relates because we're all talking about kinematics, dynamics. We're talking about Kepler and Newton, and which of course is kinematics and dynamics. Newton's just tried to insert dynamics into Kepler's kinematics, and then we deduced that big G is also not relevant for making measurements of little g, which we showed with math. And then we're of course saying we can also derive the value of big G using not attracting mass, not Cavendish, not massive spheres. So there you are.
Shane's being a salesman again.
What am I selling? Do I get paid? Could somebody?
Only if someone tries to bet you against your flat Earth eclipse predictions.
Dude, that is true. Power to Morty for making true on that bet that he made with his big
That's
mouth.
crazy. I know, right? Total respect to Morty. But Uvaldi, real quick, do you know the difference between kinematics and dynamics, real quick?
No, I guess not. No.
Okay, well that's very important for the
Well,
discussion.
please elaborate then.
For little g and big G. So dynamics are like the cause, like why things happen the way they happen, and then kinematics is just describing the motion. Like you're just watching something. Just
Dynamics would
And
be
what
the prediction of
relevance
future
does,
motion
does this
based
have?
on real forces.
there you go. That's a better explanation. Sorry, I'm super baked right now.
Just got back and heard kinematics and dynamics.
There you
I
go.
tell you what, I've had some of my best meditation sessions while being baked. So good on you, man.
But yeah, kinematics and dynamics are basically, they get conflated to be the same when discussing these, these topics about physics and stuff. And I can't really explain it right now, but dynamics and kinematics, like I didn't realize how important they were until you start talking about like relativity and just classical versus
Just anything.
Yeah, pretty much anything to do with physics. It's
Okay,
so
okay. So what is the relevance of bringing it up then at all? If we
Well,
if we're
Big
not sure what
G.
the difference is, why are we bringing it up?
Well, no,
because
we
of
know
big G
definitely
and little g.
the
Well,
difference.
So
Go ahead,
kinematics.
Shane.
Kinematics. He's still wondering what it. Kinematics is things move. Dynamics is why they move.
Yeah, because we're trying to compare little g, and you're saying
So it's
that
kind
you
of like a
have big
law
G.
versus theory.
exactly.
Okay.
In fact, you know how did you ever see the Magic School Bus when they talk about how a bill becomes a law or whatever? There's a similar thing for, you know, physics where it's like your kinematics, right? They start off as like a little bill and then it goes up to get tested in dynamics. And if it holds true, then, you know, it's likely that it's true, becomes a law, etc. kind of thing.
I think that's Schoolhouse Rock, but I love it.
Yeah, Magic School Bus was Lily Tomlin.
Either way, it works.
I was going to let him ride with it.
He was in
Now-
the zone.
Yeah.
Now there is a
Conjunction,
president
junctions,
physicist
what's
who
your
can
function?
veto the new law or whatever, should he choose.
I'm just a bill. Yeah, I'm only.
Dude, you know exactly what I'm talking about. You've seen it.
Yeah.
It's definitely Schoolhouse
Of
Rock.
course,
my
I've
dude.
seen it, man. It's awesome. I
Yeah.
grew up with it.
Yeah, that's Magic School Bus.
Oh, I hope and pray that they will.
Yeah, there was a time in our history when we taught our children civics.
Are you telling me that there was 2 children's cartoons that featured a tiny school bus and an adventurous teacher?
Maybe, but yeah, it used to be called civics, and then the next year it became social studies.
Man, where do you get like confidence to complain that Big G actually runs the world and is totally verifiable and is the exact reason why everything falls? I'm just curious,
When
man.
nobody
They told
has
me
Evidence.
to. Evidence.
We just went over
Let's-
kinematics, dynamics, little g, big G, deriving little g on the spot, function on kinematics. Remember height and time it takes to fall, right? 9.8. That's empirics. That's kinematics. That's just a measurement, and it doesn't tell you either way. That's
What's
what we went over.
empirics again, Shane? That's important.
That's what is empirically observed.
Exactly. No one denies little g.
I would
Shout
say
out
we
to the
love
little G's out there hanging out.
I think
Yeah,
we're little
exactly.
Shout out all you
fans.
G's out there, man. We got you. What's up there, Steve? How you doing tonight?
Nick KG, what is up, man? The return. And everyone else, Ken, Conspiracy, TM, Mr. X, Shane, Alan, Stone, and everyone else. Who always good to come back and do a little Flat Earth Friday. I'm kind of putting myself out there. I was having fun with a video. I posted in the chat, and I put it up there in the heavens. Playing with a little bit of the dynamics and the functionalities of this realm. So those of us that know and are aware of what true Earth really is, I was just having fun with a video, putting some stuff, some like compositing some edits and putting it all together. Ultimately, just kind of reviewing the functionality of the toroid. Because that's basically what we're talking about, and it's what all of everything in this realm, how it exists, how we formed, how we're existing, how we speak, everything energetic, basically produces and functions with the toroidal, action and reaction. And so the quote unquote science behind toroids, the more those of us that try and comprehend and wrap our minds around true Earth and trying to explain to others what we're dealing with here, I think, to me, one of the ultimate bases is looking at the toroid and, getting used to that. And so I was just putting that video out there to kind of let everybody check it out, see what you think, critique it if you will. For the true earthers, I don't really care for the nonsense from Globers, but nonetheless, it is a learning experience. And if anyone likes to chime in and grasp, what I put together, greatly appreciated. again, just kind of going over a lot of the mechanics and to become more familiar with, knowing the information a lot better. That's it, guys. Just, shouting out to everybody, keeping True Earth alive, just fight the good fight and keep on keeping on. Appreciate.
Hey man, just to be clear, because my fill function actually is broken in my browser right now, I can only review the latest 2 on the board. What you posted, is that the video you also have? That's 1 minute and 27 seconds long that you posted 8 minutes ago, 10 minutes ago? Is that the one that you're referring to?
Yes. Yeah, it's a short, quick video. I mean, I threw a lot in there. It's just like,
Okay, I got it
and
located. Good to go.
okay, cool. Appreciate it. And then I followed that up with another post of, just the, the moon over horizon over, a calm, serene image, a photo of water, just to simplify all of that in case the video is too much. If you just take in the photo of the second follow up, that will clarify everything in the most simplistic manner. And that is really all that's required to comprehend even further the dynamics of our realm.
Nice.
Okay, we're clear.
Yeah, I don't know if my video got sent to this jumbotron thing or whatever, because I'm stuck. It's stuck for me as well. Like I can't go right or left. But
If you minimize it and then bring it back up, that fixes it even in the browser, guys. Just so you
I
know.
only get the latest 2 when I do that.
If you drop it down with the arrow, collapse it, and then expand it again.
Yep.
Yeah. Still.
We do that. It comes back up, and I only get
it's
the
all good.
latest 2.
Then you only get 2? Huh.
Yeah.
Don't hit the arrow. Do a swipe above the arrow with the finger.
No one's on their phone.
I'm not on my phone, dude.
Come on, man.
I don't do phone. I do not do phone. You know what I'm saying?
But yeah,
I see
Chris,
your
that
post
video's
up
in
there,
there
Beast,
for you as
please.
well. Okay, it's up there for sure.
There's a
Chris.
YouTube video up there. It doesn't say anything. Just says it's your post 19 minutes ago, and it's a YouTube link.
Yeah, that was for I should have tagged him probably, but that was for Chris about the Steelman of basically the equinoxes and seasons on the flat Earth, how it's just based off of the sun. So I just sent him Anon's video of what that looks like from Solarium. It's pretty cool. It's a good visual.
Yeah, I am driving, and I am using my phone. I'm a globie, I guess, right?
No, you're good, dude. Whenever you get a chance to look at it, I would recommend watching it. But it brings up also another good point about what makes more sense is that the sun is actually, it's close and local, and that it's harder for the heliocentric model to explain temperature distribution, right? Like imagine a giant ball trying to, distribute heat to a tiny golf ball, right? Like and then still have the poles be icy.
Why can't flat Earth triangulate what the distance to the sun is if it's local?
Wait, what?
Why can't flat Earth triangulate what the distance is if the sun is local?
It doesn't occupy a physical space, physical location in 3D space.
Because it's
not
not
a
a
physical
giant
object.
glass ball. It's an apparent object.
Do you know how you guys triangulate it? And have you ever done it?
Have I ever done it personally? No, but yes, we're able to, and that's how we're able to.
Are you
What's this
sure
we
about
shit
that?
then?
Was
They've moved the sun like 10 different times.
Yeah, I keep hearing a lot of we.
Besides that, but did you understand that predicament that you guys have? Is that you have to have heat distribution, from a giant heat source to a little heat source spherically, and still have the poles be icy. Like try cook a turkey that's frozen, right, with a giant ass heat lamp and keep the poles of it icy. Doesn't make
Just
sense,
because
huh?
just because you don't understand how it works doesn't mean that that's not what happens.
Well, it's worse than that, Evolved, because there is this matter of asymmetry in climate,
Exactly.
north to south, latitude per latitude. It's a video that I did. So I invite you to hit BitChute sometime. You can check it off my bio too. The link's right there. It's the the Man of Stone account, and it's the one on climate symmetry, where when you take a coastal spot, a town at 66 north and 66 south, one each, so they're both on the water. Very similar types of habitation, but for what you see around them year to month to month. Anyways, you take their climate data, their temperature data off of timeanddate.com, and you superimpose it and you offset it 6 months because seasons, right? And what you find
Right.
is that in the warm season, the summer of each, there's a 12-degree Celsius difference in average temperature for that season. North to south, same latitude, towns on the water. That's why up north, there are 1,200 kinds of flora and fauna across the north. And down south, you've got penguin, seal, walrus, seagull, and a lot of fucking ice. There's not a lot growing down there, not a lot living down there. There's 100-mile-an-hour winds down there that you never see in the north. There is just tremendous asymmetry in climate, north to south, latitude for latitude, and the globe model doesn't support any of that.
How does the globe model not support that?
Requires symmetry. We have asymmetry.
You're the one talking about what about the sun going around at 23.4 degrees north, then south, then north, then south, solstice to solstice, right? That's supposed to provide equal heating based on aspect angle to the sun and albedo of the material, the ground that's on the ground in terms of reflectivity of the sun's energy. That's what produces the heating effect locally of the sun on the earth. This is the whole globe model, why it's snowy at the poles and hot at the equators, because of this seasonal thing that's going on because of the tilt of the earth as it goes around on the ecliptic around the sun. You can sing along, right? You know this part? That there is symmetry there, that North Pole, when it spins at night, you always see that we're pointed directly at Polaris, far, far away, so that the orientation, precessionally speaking, of the Earth does not change more than 1/2 of a degree per day, round and round, around that same spot in the sky. So the same orientation to the sun in the globe model is going on. You know all this part, right? So when you finally swing around, it gets hot in the north, and then you swing around again, it gets hot in the south to the same degree, right? Because the orientation of the earth has not allegedly changed 6 months later. Uval, do you understand what I'm saying? And causally speaking, how that would necessitate symmetrical climate, latitude for latitude in the globe model?
In layman's
I understand what you're saying, but I don't think you're making an argument.
No, he is. He's making an argument. Listen. This is what he's saying in layman's terms. It's different climates in the north versus what it is in the south. And there's equal supposed heating. So why are there drastically different climates? Do you understand that?
You need symmetry, and it's not symmetrical. That's as simple as we.
It's way colder in the south. Look at the winds and it's a way different. That's what he was saying. There's less animal. I mean, he put a lot on you there, but do you get what we're saying now?
In the north, in the summer, it's 12 degrees centigrade on average warmer than it is summer in the south.
The same latitude.
All the time. Every summer. Every year.
That's so weird at the
degrees
same latitude.
hotter. It's latitude for latitude. To it. Yeah, exactly.
Dude, that's so weird.
Same degree.
Do you understand what they're saying of Uvalde?
Yes, I understand, but I'm failing to see how
Well, they're both
how that supports anything.
they have temperature. They're both touching space, man. They both get equal amounts of sun.
Listen, on your
What
model,
it does
listen,
is disprove heliocentricity is what we're doing here. We are shooting down the Globee model by citing this empirical evidence, which has been going on forever. There is this abundant growth going on in the north, flora and fauna, in terms of species number and coverage. And in the south, it's a white fucking wasteland.
But the globe model explains this. Like there's a reasoning behind it. So
what is it?
What's the reason?
What is it, man? I'm waiting to hear it. I've been waiting years to hear what that is.
okay, well here, let
Sure,
me pull it
man.
up real quick.
Go ahead. Tell me why it's asymmetrical.
All right, we've never
Tell me
looked
why
on Google before.
there's just less sunlight in the south latitude for latitude. For some reason, it's just colder there. It's
It
just
says
it's a
yes, the
space
northern
thing.
hemisphere is generally warmer than the southern hemisphere. The average surface temperature of the northern hemisphere is about 15.2 degrees Celsius, while the southern hemisphere is averages around 13.3 degrees. The difference is a long-standing feature of Earth's climate, with temperature difference of approximately 1.5 degrees Celsius.
Yeah, why?
Several different
You're
reasons.
lying.
Okay, landmass distribution. The northern hemisphere has a larger proportion of landmass compared to the southern hemisphere. Land heats up and cools faster than water, so the northern hemisphere's landmass contributes to a higher average temperature. Then there's also
Okay, that's a mathematical fallacy. You know what they're doing there? You just skate over it and you think, oh yeah, that sounds logical, but it's not.
But I do know that land heats up faster than water does.
It
So,
doesn't matter. The point is that it gets
but it
heated
does
up
because
half the time and
there's far
cooling
more
half
land
the
in the
time.
northern hemisphere than there is in the southern hemisphere.
The point is, how much heat does it hold? What about its thermal conductivity? I mean, like seriously.
What about
Remember, but wait, remember his example?
What
Baldy?
should we be seeing?
No, but his example was specifically it's the same latitude, just north and south, right? And it's also coastal, so the temperature and or the environment's the same.
Yeah,
that's his point.
that is true.
It's not like that answer that it's just because of land distribution and the difference between the north and the south is a non-answer answer to that empirical, data essentially. If it's empirical, I don't know what you're referencing, Stone.
I'm referencing timeanddate.com data that goes back in one
yeah.
case to 1985 and the other case to the 90s or whatever.
Which location?
There are two locations.
Wait, you made a video about this. That's
yeah,
right.
I did. It's on
That's right.
BitChute. You can just
share it.
Just type in Man of Stone climate asymmetry, or just climate actually. Man of Stone, all one word.
You should share
and
it.
Climate, and it pops right up.
Yeah, and there being more land up north and down south isn't even the only reason why. Like, so there's explanations,
what are the other explanations
as to why these things happen. So to assume that the Earth is flat because you don't know is it's outrageous.
Hold on.
I went to Grok. Just real quick, I went to Grok last night, and it gave me explanations, like 6 of them, on why a translator could understand Stephen Hawking sounding like Chewbacca, right? So Grok will tell you a lot of things, and so will Google, and that's the only point I'm gonna make. And a lot of people, it'll polish a turd up real nice for you.
Grok has the innate intelligence of a Cocker Spaniel. And all it wants to do is earn your little doggy treats, one request at a time.
Didn't somebody say that Grok's IQ is set at like 110?
What does that even mean?
That doesn't even mean anything.
IQ is all about how quickly you learn things. So that doesn't make any sense.
Grok will tell you that Ares' failure was about measuring the ether. Is that true, anyone?
Negative, Ghost Rider.
Like,
if you didn't read
papers and you read Wikipedia line one time, then for you, yeah, that would be true, I think. But if you look into it at all, then no, that'd be the opposite of the truth.
But AI is dog shit. All right. There's a reason why they have to create iterations over iterations over iterations because of model collapse and entropy, literally. Like Sam Altman just went on record saying, like, could you guys stop saying please and thank you? You're costing millions of dollars in compute. That's so funny. Everyone's trying to be nice because they think fucking AI is gonna take over. It's hilarious, dude.
That is objectively funny, yes.
But the point being, Uvalde, is like, you gotta not appeal to credentials or appeal to authority and look deeper than Google page 1.
Yeah, we got a lot on the side.
No, I agree with that, but these are very valid explanations that support things. I mean, I agree with.
For instance, that
Hold on, wait,
first,
don't interrupt them, bro.
I'm sorry, I apologize. Go ahead, Uvalde.
I agree with, not taking things at face value, with not appealing to authority. I mean, I agree with all these things. This is part of thinking critically, but there has not been anything that can substantiate a flat Earth. There's been nothing. All evidence points towards a globe.
Nothing.
Earth.
We came up with zero.
Have you heard of the
Absolutely
celestial
nothing?
theodolite? 37
Nothing?
measurements, mutually exclusive, only supporting flat
dude
Earth
just
and
say
excluding the
nothing?
globe every time?
This
That
kid
sounds
just
like
said nothing.
Yeah, I mean that sounds like a very cognitive statement.
Chucky
though,
Chan.
Like that was a very large platitude you just said.
I feel like I
The
just
Karate
triggered
Kid
a lot of
again?
you guys.
Uvalde, the problem here, Uvalde, is that you're just underexposed.
Yeah.
You haven't seen it all yet, man, and you shouldn't be making.
Mason's gonna want to see that
based on
movie.
How little you
He's
know.
not gonna
Karate Kid
Why
Legends.
can't flat Earth?
man.
Why can't flat Earth make a prediction
Yeah.
for when the next eclipse is? Why can't flat
Dude,
Earth
we
tell
went
me?
over eclipses.
Hang on.
I can't
Hang
believe
on.
you're
Why
saying
can't
that
flat
right
Earth
now.
tell me how far away the sun or the moon are? Why can't flat Earth explain why things move downwards? Why can't flat
Dude,
Earth?
you think because somebody told you the sun is 93 million miles away and 400 times bigger and 400 times further away from the moon, that's actually because they told you the story that what? Are you kidding me right now?
We can explain all those things.
If you can provide evidence that supports that being wrong, then I'm down to listen.
But real quick, Uvalde, we literally Shane just went through it. Like literally just went through it. I just want to ask Chris, who's also a glober, have you been listening? Do you remember what Shane's explanation was about how it's cyclical? If you were listening, just you can kind of steelman it for Uvalde so it doesn't feel like he's getting attacked over here, but
Well, I think he's just gonna say nuh-uh. I mean, we went through observer-centric observations, right? We went through kinematics and dynamics. We went through the actual eclipse predictions are just based on periodicities within the lunar cycle, based on perigee to perigee, node to node, and lunar cycle to lunar cycle. And when those realign, you get the Saros. Actual eclipse predictions are just based on periodicities within the lunar cycle, based on perigee to perigee, node to node, and lunar cycle to lunar cycle. And when those realign, you get the Saros cycle, which is 18 years and so months, and an offset of 8 hours, and that repeats 120 degrees around the world, right? Which gets you the exogemelous cycle, which is the same eclipse repeating in the same sequence, 1/3 around the world every 18 years, and so on. From there, they build the Saros cycle, which is actually spread out over thousands of years. If you look at actual solar and lunar eclipses in sequence, though, they actually always repeat in the same order. So it's like total annular, total solar, annual, like every order like that repeats into a series of 71 and 70. And then that repeats into an actual cycle of 651 years. So all of this is known. Fred Espenac actually stole his data based on only geocentric observations from a French guy who put it out in 1890, who actually stole it from another guy who had published predictions from even before that. There's a book from 1500s where they had the same data published. They even had a a form of latitude longitude.
Slow down, man.
Latitude
Yeah.
Slow
longitude,
down.
so they could graph it, man. But the whole thing is that it's based on observed periodicity. It has nothing to do with mass attracting mass or three body problems being solved to predict the motion of 3D bodies in space. When I did the solar eclipse prediction for the path of a shadow, all you had to use was the fundamental plane and a coordinate system with a series of expressions for, like, say, X and Y would be above and below, to the left and to the right. And your 3D plane with the fundamental plane through the center of the observer. And then you have functions on the end like x squared or cubed, and that would define the nature of the curve on the graph. And that's how you get the prediction of a shadow for a solar eclipse. None of that requires the heliocentric model. All the people who say that haven't looked into it that much is all I'm going to say. All the data that NASA purports to have predicted is actually based on cycles, which they accredited to Fred Espenac, who, like I said, stole it from the French guy in 1500s, who stole it all the way back.
Or you can bet him 10,000 to see if he was making that up just
Bro,
now. Like,
This is
said we had
this is a common tactic used by flat
We
earthers.
absolutely got nothing.
No, I want to hear what he
nothing to
says.
the table. I was not convinced. I go on everything. It can all be explained away with refravity, man. It's either refraction or gravity. Y'all are stupid flirts. I was not convinced at all.
Time out. Time
This is
out.
a common tactic used by flat earthers where they just throw out a whole bunch of different
Bunch of
things.
Can you
Don't
say
say
one
things. Bunch
thing?
of facts that you're unaware.
Jesus.
just because you didn't understand.
I tell you what.
don't understand it doesn't make it
Since I can't talk, I'm just going to let you guys
heard
talk.
what he said
You
yet.
go right
keep on
ahead.
complaining about that, but you got to speak all day long, man. You act like you get the show. Every time you speak, anybody else has got to just shut up and listen to you. But you don't seem to listen. You said we literally brought nothing to the table. We got nothing. Nothing. Those were your words. We got nothing. I mean, Shane just threw out everything. Went over eclipses with you, the Saros cycle, everything, and got nothing. You didn't even say, that's interesting. I might look into that. Nothing. We got nothing. That's absolute insanity right there, bro. Are you kidding me? And you say, oh, I don't let you talk. Are you kidding me? You came back with, we got nothing? Really? So anyway, let's put a pin in that real quick, man.
No, you don't let me talk at all. Every time I try to say something, you guys interrupt me.
all day long. So don't even act like you haven't been able to get to talk.
You haven't muted people, but it doesn't mean that I can't say a fucking sentence without
I get it.
being
You're
interrupted.
upset. I get it. But we're gonna say hi to my buddy Orwellian, man. What's up, Orwellian?
Hey, dude, how's it going?
What up, Orwellian?
What's going on, brothers? Brothers and sisters. So, ironically, everything that Shane laid out seems to, a lot of thinking and a lot of math and a lot of shit. But the astrolabe and the prog clock still work accurately and predict that. So I'm just going to take it back to the archaic. Anytime we get placeholder arguments and all this other shit, or explain everything that has ever existed in the universe, I'm going to go back to things that still function, that you can hold in your hand, that don't need to be calibrated.
Did you guys lose? Were you finished, Orwellian?
I don't get it, man. No, I just don't understand why those things still function.
Right? If everything's moving around and they can predict it with 3D space and gravity, why does the thing that built 2,000 years ago on an astrolabe, how does there's a Mayan eclipse predictor that predates the first astrolabe from Rome, from a Mayan society that was also predicting eclipses based on the lunar cycle and the known coincidence of the three lunar periodicities, because they know that it's exactly 6,500 and so on days, which is 18 years, 10 months, and 8 days, right? It's crazy. So if they can do the whole cycle prediction based on that known ecliptic cycle, then of course they can still do it today. If you look at the astrolabe and the prog clock, all the things that are on there are actually what you need to predict the eclipse. It's like the sun's ecliptic, the path of the zodiac, the phase of the moon. They're using a lunar calendar, so like they can use there's a lunar node predictor on there, so it knows exactly what phase the moon is in and what node it's in, which is 2 of the 3 periodicities you need to predict it, right? So fantastic. You can use the prog clock to predict eclipses. Fantastic observation.
Yeah, and yet we get people that are arguing that, hey, explain this, explain that. These placeholders that have been created by heliosorcerers are confusing me, and nothing that you come at me with makes any fucking sense. Yet again, I like to just go back to the the archaic at this point. Things that still function, that don't need to be calibrated, and don't really need to be explained in that great a fucking detail exist, and they exist for a reason. The question for a lot of the heliosexuals would be, you know, why do these exist and why do they function? But no, we don't get that. We get explain how Einstein hijacked Newton. And dude, it just gets so fucking exhausting. I get so tired of arguing over the same points. Like, we have conversations about Aries failure every fucking week. And it's like, okay, I get it, right? We're debating the same fucking thing every week because you don't understand and you're not going to understand. But that aside, and all the placeholders that were created for all these different fucking theories can be put on the back burner with something that you can hold in your fucking hand and that works. It works. Ask yourself, why does it work? Globies. Why does that fucking work? And how are we wrong?
Bro said we got nothing. We brought nothing. I mean, if you're down there on the fence and thinking about stuff and you heard him after, the dude been in here, we've been going over stuff all day long with him in detail, and he acts like we brought nothing. Any Globy down there that's like, I don't, to say we brought nothing, not one thing said, well, that's curious.
That's pretty wild.
I think we did a pretty good job with little g, big G, kinematics, dynamics, physics, observations, Kepler, Newton. I think everything that we went through,
dude, it was
on point and
actually
relevant.
a pretty good conversation up until the point he said we brought nothing. I was like,
you were really personally butthurt about that.
I know, right?
Like,
You
fuck
guys,
this guy.
you provided way too much sauce. That was the problem. Like, if you just said, "Hey, man, there's patterns in the sky we observe," like that would have been, I don't know, something he could have like comprehended or taken in. It was interesting. He didn't know one thing you said after you had said it like 3 times.
I think that's the key point, is comprehended. And I don't
Dude,
think he
Alan,
comprehended much of it.
yeah, definitely overdosed on the sauce. And then the icing on the cake right when I came in was reciting, you know, empirical climate data that's been, you know, collected over the years, and just basically reading verbatim Google's explanation, which is kept information as a gotcha. I was like, okay, well, I'm checking out.
I get the frustration now, Brian. I mean, we just popped in here, and I don't know, that guy Chris, I know he's driving right now, but he had a good faith question, and I think that's what it's for. Like, you know,
oh, that answer, man, if you're on the fence, I mean, you got to be like, well, I got to look into that. I mean, because there's no way we didn't bring something.
Right.
Dude, we've looked into it quite a bit. We actually do this for fun, as we used to
It's
say
fun.
with Sacred, dude, right? This is what we do on a Friday because we choose to be here and talk about the stuff that we entertain. Like, we know so much about stuff because of Twitter, because somebody one time was like, flat earthers don't know nothing about eclipses. And I was like, you know what, guys? I'm going to go learn a shitload about eclipses. And I'm going to tell that guy to go fuck himself. I remember having that conversation and then just spending the weekend collecting data, having Toby OCR some of the stuff so I could extrapolate it into Excel so I could rock with it and do whatever I was doing with it. I remember doing all that. And then I remember learning way too much and trying to build a presentation out of it for the boys that ended up being 3 hours that nobody like watched because it was so dense. And then I had to parse it out into stuff. I remember all that, dude. And Alan has some of the similar stories for relativity and Einstein on all that shit.
Dude, I tell you what, man, that's how I really did, because they kept on telling me that I was stupid. I need to go back to school and learn the basics. So it's like, you know what? Well, maybe I do. I'm going to go back and learn the basics even harder now. You know, spite learning is fun.
Spite learning is the best, dude.
That's
so
basically
much
flat Earth.
You just spite learning.
Described flat Earth in a nutshell. Like, why are there flat earthers? Right? Or people who deny the mainstream cosmological paradigm. Essentially, you don't even have to be a flat earther. But imagine if the mainstream cosmological paradigm you've been fed your entire life is wrong, is a lie.
Dude, more than that, Imagine if the science you thought was science was actually just philosophy disguising itself as science under the Copernican principle.
His
where a
best
bunch
proof.
of scientists got together and were like, no matter what, we're not at the center, even though everything always shows that.
His
okay,
best
guys? And they're like,
proof.
yeah.
Uvalde's best proof was, you know, pictures of the globe and, you know, movies and stuff. And I was all like, you know, I see what you're seeing. Is it a possibility that those are fake? And he's all like, well, yeah. I'm all like, well, then what are you looking at here? That's not exclusive, man. You don't know if those are real. He still leans on it. Well, we got all these pictures and all these NASA videos.
Dude, he's just going to wait until I'm not here again and then come back and say that no flat earther can ever explain eclipses. I think he's one of those.
I was really impressed when he whipped out Google and started to rattle off the lies you find on their pages about how the temperature differences are 1/10 of the figure I just cited.
I think it's
he
funny that
continued to stand behind it. That just boggles the mind.
I think that people that challenge us here to assume that we haven't Googled the stuff that we're talking about is not a safe position for you to take, okay? I'm just going to say that.
Well, you know, at the end of the day, it kind of feels like we're just arguing with bobbleheads at this point. People that are just nodding to, you know, whatever was mainstreamed and whatever, you know, the globe they placed in front of you, even though we abandoned the Easter Bunny and Santa Claus, you know, they're just bobbleheading at that. So, you know, it's not a surprise when you get somebody that's super passionate about being wrong, yet they come, you know, they come with that energy. You know, you can be really passionate about being completely off base, but you're still off base, so the passion really doesn't matter at that point. Just bobblehead on, buddy.
Did I call them Google Earthers because their entire knowledge base is whatever Google says. Literally, I think I've asked Drew Hip what he thought about something, and he was like, I don't know, Google it. That's what I think. I was like, wait a second, what? So yeah, whatever Google says is actually my answer. And I was like, oh, hold on a second. I don't even need you then, right? I can just, if I wanted your opinion, I can just Google it. Is that what you're telling me? Oh, okay.
So you let Google think for you, and that's
if I don't know, whatever, and not even like the second or third page. Like, God forbid you want to go past the ad paid curated nonsense page that all the big tech feeds you before you get to the actual results of this curated internet you're allowed to see.
He says, slow down. And then he says, you're a good salesman. And then he said, all you flat earthers are the same.
He started saying that. I was gish galvin, right? Like, you all just throw out random. They make it sound like I'm just throwing out random facts in a sweat. Like, oh, I know this. And I know this. And it's like no, that was a string of related and coherent and interconnected data points that painted a larger story in a logically cohesive manner. I think. It wasn't like just random stuff.
A bunch of stuff in there and like threw out like the best tire pressure is 30 pounds PSI.
Here's all these facts I know. You know, some just I know.
Random stuff out there just really fast. Yeah. And he wasn't going to catch that. You know.
Oh, yeah. I mean, imagine relying on Google for the best tire pressure and ignoring the manufacturer's specifications and, you know, the curb weight of your vehicle. Yeah. I mean, go ahead, guys.
Brought nothing to the table. Man.
I still want to know how
I think we put in a good effort at least, man. Nice showing, guys, but yeah, nothing. Brought nothing.
It's always nothing, dude. And then I even mentioned celestial theodolite measurements of like 37 different measurements, 7 peaks or whatever. So, like, of course, they're like, you never bring any measurements. And it's like, here's a whole slew of mutually exclusive, never before been addressed measurements. Could you be the first one to address them?
You came with 37, and that requires somebody to take off their shoes to count that high. And then they can't even get theirs. They got to borrow toes, fingers from their cats, gill plates from their fish, whatever they have for pets. So
that was a straight up nuh-uh. Just to everything, nuh-uh.
I still want to know how gravity causes curvature.
Refraction, bro. Trust me, bro.
He wouldn't accept. I mean, still don't get what he was trying to say with the. He couldn't accept the fact that the higher you go up in altitude, that the less refraction you have to deal with, even though it's still there.
That's true in the globe model for sure, though. That's his favorite thing when he talks about 7 over 7/6R, of course, invoking the radius, but how he likes to get above the surface at 100 meters so he can make globe predictions concurrent with 7/6R. And that's what any glober will do all day long. And he's like, if you, this is why I like Ruha, because like, if you argue with me about surface level observations, like he'll literally invoke refraction to an infinite radius so that you could almost see your own ass. You won't say you can see your own ass, but I'll use the math necessitated by seeing your own ass, right? That's pretty much what he said, and he was kind of joking about it. And he's like, "That's why."
Comfortable with it though. He
Be
admitted
comfortable
that.
with exactly
Yeah.
saying that. That's why you want to get me to
He
argue
literally
above
admitted
100
that.
meters. And I was like, you know what, Riff? On hearing that, I don't want to argue with you at all.
Hey, you guys want to give Alan his mic back? And D3's down there too.
I
just sent him one.
Invite.
Nice.
He might be on a phone call.
Yeah,
or
he might
something.
be
no,
putting together some Prezi or something like that. He said something about my DMs here that let's see what he said here. Let's see what he said. He said something about get the lads fired up for Airy and sell Theo tonight. So I haven't heard much on the Aries failure there. Apparently, we have some smoke coming here.
Yeah, I get it. I mean, anybody
testing.
actually, and anybody on that end of the spectrum, and I think they're on the spectrum to an extent, all of them. Have any of these people publicly tried to debunk the function of these devices that I mentioned, the prog clock or the astrolabe, their existence? Have they denied their existence as being relevant in this conversation that we seem to have every Friday? And if they did try to, do you think that they would be capable of, say, debunking the function of the astrolabe, for example, or the prog clock? It's something that I'm interested in.
Yeah, Uvaldi just messaged me and said that the conical projection of the sky to the ground, it only works on a globe, so your astrolabe belongs to him. He said specifically, quote, all your astrolabes are belong to me.
Cute. That's cute, dude. So he's the owner of the astrolabe now. But no, I mean, it's just something that just crossed my mind. I'm like, the conversations we're having is, all right, well, hold on. This is your positive claim, and we're trying to, learn, what we're actually fucking talking about here. Come at it in a coherent manner and have a discussion about whether, whether it's debunkable or not. Can you debunk these devices?
Dude, you will not get rational from them. You will get assertions that those two devices prove globularity.
Yeah, if we wanted to steelman it nicely, right, the best argument from them would be like, sure, they have a vague level of predictability. However, you need the globe to predict the path of the shadow. I think that's what the average glober like a McToon would say, in which case, we've already destroyed that with predicting via the X or Y coordinates, the Besselian elements, and then just using that as a function of the polynomial. So you get squared or cubed to get the degree of the curve, and then X and Y to be above and below and left and right. And that's what plots it on the graticule. So I think that the average one would be like, sure, the prog clock may do some of it, but you need the globe for the rest. And they don't know the story.
Here we go.
So they basically
Graticule. Here we go. Graticule. Yeah.
So are they just do they just invoke another placeholder to dismiss it outright? Then that's kind of okay. I got to reach into this bucket of globe tar and smear some shit on your device that seems to still function properly without calibration.
Like if you read it from flatter.ws, it'd be like, sure, the Saros cycle can make predictions, but not to the second of the time of the heliocentric model without providing any proof to anything like that, right?
I was just curious. I've never actually asked that question or even really thought about it. We always focus on, debating and attacking their bullshit and all the placeholders and the magic. But yeah, man, I'm super interested in these things that we can hold in our hands that still work.
The thing is, though, if we asked the Globers about that, it would be like 30 minutes of ad homs, then they would duck and dive, then they would adopt our premise as their conclusion with triumph, right? That's been happening a lot. And then an hour later, we finally get to the point where they'd be like, yeah, actually, what you're saying is true. And really, we could have just asked AI and we would have got the same answer. Like, okay, well, sure, it makes some sort of predictability, but you need heliocentricity for reasons. That's what it would come to.
Yeah, it's always a yes, but
Bark,
is
bark,
basically
bark.
the answer.
Tongue hanging out.
Yes, but, and then that's it. And insert assertion.
It's just gross. It gets exhausting sometimes.
Yeah, it does.
Shout out to all you guys that hang in there and don't even sweat it. Just like, dude, I want to fucking freak out on some of these guys sometimes. Same argument, same bullshit every week.
I mean, there are some people though that want to have that good faith conversation and actually ask a question. And even if it's just one person, it's, I don't know, it's worth it.
Oh, it's always worth it. It's just difficult to actually, like, it seems that there's a scarcity of people that want to have a good faith debate these days.
It's seed planting. You do it where you can,
Yeah.
Yeah, we only get to really talk to the anti-flat Earth troll monsters with, like, Dr. Jekyll, Mr. Hyde, freaking fetish fantasies that turn into goblins who attack you. It's hard to get stalk you everywhere you go. We don't really have normal people who might have watched the science special who think that they know about galactic accretion and how the solar system formed, right? Like, those are the people that we want to talk to, but they don't come in and talk with their chest to a flat Earth space like this, it seems.
What happened to your boy Uvalde?
We
wore him out.
Dude, he straight beezied.
I think
Yeah,
Brian was gonna ask him either way. Nothing. How's this for nothing?
I wasn't gonna ask him, but
nothing right
that's
here,
why he
buddy.
left. He's like, yeah, I don't know. Yeah, that was a piss poor retort. You guys got nothing. You brought nothing to the table.
I expect more from Uvalde. He's a good lad.
It was polite, but the thing is, he takes so long to say things, and he says a lot of ahs. So everyone like Raptors hears like two ums, and they're like, I'm talking, I'm interrupting. So it's not really our fault. Everybody did it. He speaks really slowly, even though he's super polite. That's just my observation. I'm sorry, dude. I'm sorry that happened to you.
Well, he would cut everybody else off, and no one really said anything. But if you cut him off or anything, it's like, oh my God, persecuting me.
I'd be trying to hear what he says, and then and I'd be like, come on, and then someone else would just give up and start speaking. Like, couldn't really get mad at him, right? Because it took a while.
I kind of have a fundamental problem with the Globies who repeatedly make use of the phrase "flat Earth can't explain X." Like there's a dude with flat Earth on the front of his shirt, and it's hey, flat Earth, yeah, that guy owes me $50. Oh, flat Earth, yeah, I know that fucking guy. His hair's fucked up. Yeah.
To be fair, I like to
That guy.
wallpaper my room with those requests. Like, I like to seek them out and find them and try to see them as challenges.
You got to tell me how tides work if the Earth isn't spinning.
You know what that guy said several times? He said the globe explains everything. And then when we say, okay, we'll name one thing, and then it's like a little harder. It's like, well, and then, we just witnessed what happened there with the eclipses.
No, it was fun watching him overload. Shane gives him a full slate explanation. He goes, "Oh, that was all just horse shit." Really? Which part?
That was the longest ever, wasn't it?
What do you think about that? Shit,
Dude,
I don't know, man. All of it.
The really funny thing is that we actually went over this with him earlier, and we said, if you wait a little bit later tonight, Shane and the boys will come in here and, give you all the deets on that. And, well, you did exactly that. And so it's not like you were the first one to bring it up today.
I think Alan's basic steelman of it in a preface was also sufficient to prove the point. He definitely nailed the whole story. So, I mean, if he wasn't going to listen to anything I said, he got the whole thing from Alan, and he still was like, nah.
Yeah, he just told you to slow down. Hold on, man. Pump the brakes. Slow down. I'm trying to process this. And it's like, really? Well, explain to me why I stub my toe if mass doesn't attract mass. What the fuck, dude?
Tell me why an anvil weighs less on Mount Everest than it does at sea level. I was like, who did that? Oh, you're saying it doesn't happen?
We like to explain the things. They're like, flat Earth can't explain. It's like, well, we probably, someone here probably can, though.
The invocation of an anvil also goes, oh, why can I float one in Mercury? We don't want to talk about buoyancy versus density, though.
I was like, why would it float in Mercury but not in water?
I like when he told Shane to slow down. He didn't miss a beat. He like sped up.
He was like, all right, I'll slow down. Not.
He actually did slow down. I was like, oh, I can dig this pace.
Trying, dude. It's a lot in the head. It's not like I have a script, right? He thinks that we read scripts. No, I'm recalling that off from my head, and then I'm like, oh, if I don't jumble it, these 4 parts aren't gonna fall in sequence, you know? So let's go a little faster.
Does anybody accuse you of being an auctioneer for a living? Does anybody that can read a script that fucking fast, bro, is doing that for a living, for sure.
Nope. I think Shane's just high and has a lot of information he wants to share in a short amount of space.
Nailed it. That's exactly the circumstances that produced the effect.
Yeah. And if you're a real trooper, you go to one of his YouTube videos and put on 2x. Good luck.
Yeah, that ain't happening.
Just kidding. It's not that hard to
I
follow
think
Shane.
Winston said he can do it at 2x or whatever.
Yeah. Once you understand the topics, it's like, oh, you just understand the order, basically. It's like,
To be
fair,
you know how the song goes. Yeah, sure, man.
And all the presentations, I take time to go much slower, and it's all the visuals are out there. We do them, and every time they get better and better. But
I was gonna say,
sorry, go ahead.
I was gonna say maybe by the 3rd or 4th listen I'll be at 2x, but yeah, not the first.
It takes a while to reduce something that is like what it would take me an hour to explain into like a 5-minute dissertation, into like a 2-minute summary. That's a hard task, because I don't know if it sounds hard, but it is pretty hard.
It's super hard, especially with all the topics that you have to go over just for like one experiment. It's like, all right, what's
you gotta
this?
learn
All right,
something new for yourself, right? Learn, explore it, test it, and then relay that to it in its entirety to a whole new group of people without throwing your interpretation on it. It's definitely hard.
Especially when you learn more information about a subject. It's like if you're building upon a different subject, you're like,
But there were other individuals who utilized it nefariously. You could see this through a lot of the promotion links, if you will. I'm not calling out any specific individual or anything like that.
Oh, 1 second, lads. Got disconnected there.
you can't see them, but they're
Testing.
everywhere.
Testing 1, 2.
Nobody wants to talk to us.
There he is. What's up, Alan?
What's up, dude?
What's up, dog? What's up,
What's up, dude?
You
Sounds super straight.
That was the sigh of a 330, 30th gauntlet run in RuneScape.
No, I was reading about celestial mechanics and all these structures on Earth that were built that the sun intersects with them on the equinoxes. So there's some in India, Mexico, other places, like pretty much all around the world, right? We've all heard of them. But anyway, you know how they say that there's like a precession of Earth's axial tilt. Well, if any of that were true, then these buildings wouldn't be aligned like all these years later. So anyway, I was just
Your mic is
looking.
super loud again.
I was just looking at that. How's it sound now? I moved it away from me.
You're a little less loud now. It doesn't sound like you're an angry bear eating the
Oh wait,
mic.
wait.
So
How does it sound now? The
Okay,
little
okay,
volume,
reasonable.
the
I
little
think you're
volumes.
back there.
Yeah, the little volume slider may or may not have got adjusted when I was moving my mic. But anyway,
So is it, Alan, is the theory on that the precession of the sun is running on an ellipse and it's crossing all of these paths?
never matter. I don't know what that means. I'm pretty sure the sun goes in a big circle that oscillates over top of us.
Yep.
We perceive the ellipse or whatever. But anyway, all these structures were built that have, like, so anyway, during the equinox, the sun, like at noon or whatever, will be in the dead center of this, shining through like a window of the structure. There's a bunch of these all over the world. So guess who's going to be incorporating that into a future presentation? This is me. It's on Tuesday. Make sure you guys tune in.
Hell yeah.
Nice, hyping it up.
So we got Monday lined up and Tuesday lined up?
Like the amount of like model things we let them get away with when they're like, "Where's your model?" Like, bro, do you know that the sky's been the same for like forever? They build structures around it. They built guys, they built mini celestial theodolites with buildings to mark the equinoxes.
Essentially. Yeah.
That's insane. I'm looking at this. I'm looking at this building in India. Guys, it's a celestial theodolite building.
Dude, that pyramid in Mexico that has the snake running up and down it on the equinoxes, man, that's just insane, and it just every year.
Dude,
Oh, you have to show me that. I haven't seen that one yet.
You haven't seen that the one with the stairs on it? It's got a snake head on each side of it, and it has the shadow go up and down it.
No, I'm only on the India section right now.
Is they change the time of the year. They're like, look, it's at the equinox and the sun isn't at this building anymore. That's how it all processed and changes. And it's like, no, you guys had a daylight savings time and it's not really that time. That's retarded. It's like, wait a second. People were freaking out when it didn't realign, but all the ancient structures still realigned, dude. That's why they had to change the way that we would do time and change the lunar and solar calendar to get the lunar solar calendar to get 28 days and 13 months and all that crap.
Alan, you weren't talking about Angkor Wat, were you?
No, I can't pronounce these names. I'm not even going to try. It's a really long. Like I'd have to call in Liliana to get in here and do it. All right, this one's called Tirvuana. Yeah, dude. Nope, I can't. It's not even possible, bro. These might not even be buildings because you can't pronounce them. If you can't pronounce it, doth it even exist? Like, look at this. I'll put it in the chat. Stone, give it your best Indian accent pronunciation on 3. It's in the.
And it was built with hammer and chisel too, so there's that.
Yeah, it's in the jumbo.
With guys that didn't know any architecture. I mean, we got all these old writings and stuff, but no one ever found any plans and stuff. But these guys need weight distribution and everything.
Dude, it's like how you think there would be some plans left over because it's like not only are we gonna build this badass.
That one is Padmanabhaswamy.
Oh yeah, Padmanabhaswamy. Yep.
That's one of my favorite temples. You can go there all the time. You don't have to have a dog. You can just walk right in. I would recommend that you wear the right attire. And I'm not talking about the tire on your car. No.
Man, I thought you were going to post a picture of it. You didn't post a picture?
No. Oh, that was just the name so you could pronounce it. I'll post some pictures here in a second.
Padmanabhaswamy temple. You have to go there on Tuesdays for extra pastrami.
It would be a good idea to post.
Yeah, you gotta say with the Indian accent, and it's really super easy. Paswanami.
So Alan,
imagine how cool it would be to be an Indian spellcaster. Like, oh my god, that'd be insane. Sorry,
Alan, there's a couple of things that we've built recently too. So there is the Anthem Veterans Memorial in Anthem, Arizona, that aligns with the sun on Veterans Day every year at 11/11. And then we had, the Georgia Guidestones until somebody decided, hey, we need to blow that fucking message
Peace
off
be
the
upon
face.
them.
Yeah, that aligned with it. Definitely, peace be upon them. That aligned with Polaris. You know, so like, I'm super fascinated in what you're talking about all these ancient structures, but we're still fucking building shit to this day that works.
Well,
so
that
dude, what the
doesn't
fuck?
that doesn't count if we just build it. It has to be multiple years of like thousands of years of precession to like where it would change it. But what's crazy is like you were talking about earlier, how there's no plans for what they built or whatever. You know, they just have these structures. It's like you would think they would talk about. It's like, hey, not only are we going to build this, we're building it in such a way that it's going to line up with the sun on this specific day. It's like, how is that not like the focal point of discussion for the whole thing? Like, you know what I mean? Like, clearly that's significant. A lot of thought went into getting that to work out, and they're just like, nah, could have been anything.
Yeah, and I would agree. I'll retract that on just like the Georgia Guidestones and that Veterans Memorial, because we don't have enough, you know, procession of time to be able to go, yeah, this still works as things change. But
the Guidestones
clearly there are things all over the place that do, and it's fucking wild.
Yeah, so the Guidestones would have changed by like half a degree by the time since the time they had been erected. So that's why they had to ice those. So like, fun fact, right? You know how there's what's that agency called that protects us from terrorism, foreign and domestic?
Men in Black? Oh wait, no, you meant the real one.
CIA?
Team America.
Like the CIA, FBI, you know, Army, all that kind of
Team
stuff, armed
America,
forces,
World
right?
Police.
So check this out.
America, fuck yeah.
There's an unsolved domestic terrorist attack, and it happened on the Georgia Guidestones. It's like the only one that's unsolved. Some guy walked into an Oklahoma City building that had a bunch of evidence in it, blew that bitch up. They immediately knew who done it, who did it, how much explosives he used to do it. Guys, they have 24-hour surveillance. They had 24-hour surveillance on fucking stones in a field, and they have no idea who did it. There's no clue.
I believe Dan Bongino. He said that they know. So
where'd all the ammonium nitrate come from?
As soon as a building blew up on 9/11, September 11th, on the news, they were like, guys, we're pretty sure the only person that could have done this is Osama bin Laden. We're not, to this day, not even a suspect, bro, on those Georgia Guidestones. They used a bomb to explode a national monument, and nobody cares.
Wow.
Man, they knew when that Oklahoma City bombing, that was Timothy McVeigh 100%. Never mind that Hillary Clinton evidence.
A guy mailed bombs. They figured out who that was. They were like, we can't let this go on. Some guy's driving around blowing up structures. Nobody cares.
But if
you know who blew up the Georgia Guidestones, honestly, the reason we don't have any video of it and they have no suspects is it was fucking Bill Gates and Klaus Schwab, and they did it together lovingly because they don't want us to say what they're saying anymore.
But dude, we do have video of it. There's a guy who jumps out of a pickup truck, slaps a bunch of fucking explosives on it, runs away and detonates it. Fucking fucks off. No,
there is video.
It's not a national monument. That shit was built on private property, guys.
Yeah, it was built with private money.
That people broke in.
Private property with private money.
They didn't make it a national monument?
Dude, they have
I thought they did. Well, either way.
Built on private property. Yeah.
Shane, what were you gonna say? You're coming in low, bro. Uh-oh.
Did we lose them? Well, no. Anyways, that's my theory. I think that the people that support the message that was etched in multiple languages all over that were probably guys that blew it up. So they were like, yeah, we can't have this shit.
Oh.
What's going on there, Shane?
What the fuck?
That's some critical fail. Holy shit.
All right. We won't talk about the Georgia Guidestones. Chill out, Elon.
My goodness, Elon.
What is going on, dude?
Shane over there needing a reboot.
think a Jewish space laser is about to hit Shane's house.
Man, goodness. May the force be with you, Shane.
Dude, they're like the one flat earther that can predict an eclipse. Take him out. Take him out.
He's in the crosshairs. What should I do, sir?
The threat to national security.
Just Fred Espenax on the helicopter, like, do it.
Do it. Do it.
No, it's worse than that for the Globies, guys. All this talk about area that Orwellian doesn't want to talk about anymore. Well, just all I want to talk about is the fact that they took those data points. We're looking at Gamma Draconis straight up from Aries' house in North London there. And the point is, guys, that observation was very precisely taken 153 years ago. And you can go to that same spot at the equinox coming up, and you can take the exact same measurement 153 years later. Gamma Draconis will go over your zenith at exactly the same moment in time as it did 153 years ago. You'll get exactly the same measurement, even if you have the same instrument, etc. There hasn't been any change. And the Globee model simply isn't going to go, well, because space is big, things take a long time to change. You know what I mean? You can't have that and 5 different types of fucking wobble in the model all at the same time.
Well said. Such an overlooked but like easy to grasp point. Like they've been using the same snapshot of the sky for terrestrial navigation for the last
fucking totally
500, assuming their timeline is like legit skis, right? Since Petals, right? He had a latitude longitude system, dog. He literally had he had the coordinate system and a stadia. Or no, who was before Petals was who was the Cyan to guy? Yeah. So in Eratosthenes' time, they already had a stadia. So they already had a graticule.
Well, see, that's the tricky thing, because that wasn't really around till the coordinate system in like 1700s, right? The board of longitude. But when you read Greek history on how they all created the tools for the globe, but nobody created the globe until 2,000 years later, it's kind of tricky. Because like Hipparchus invented like all the math they would need in calculus and the instruments and wrote like 12 books, but then they all burned and it's totally real. And then he's actually evidenced by books that show Eratosthenes was real, which are built by books that show Ptolemy was real, which are built by Herodotus, which are sent by the old school, like Hipparchus. It's all word of mouth, and it comes back to like myth and legend, right? And actually, there's no historical references. The particular story of Eratosthenes, the whole thing that makes it a circumference measurement is he used the known distance. The only thing that's relevant and what he did was the relationship between an arc on the prescribed sphere and the distance and that he calculated based on the only observations of the known angles. So when we're like, all right, well, how did he know what the distance between Alexandria and Syene was? The actual mainstream answer is he had people called Bamatis, which are like supposedly old school geodetic surveyors, which of course is weird because geodetic surveyors compare measurements to a previously known model in modern times, like the WGS84 and the ellipsoid. So how they would have measured something by claiming to already know it is a bit perplexing. But if you look into that, that's not even true. There was no Bamatis. There's no evidence. People just assume that they use Bamatis to make the measurement because they see how important the distance measurement is in the actual calculation. And that's the stuff that you won't find on Wikipedia when you actually look into Eratosthenes.
You see, these silly globies make this weird assumption, this weird cultural pan assumption that in that age, that it also was the case that the rule of law, to command over the land. And what do you think the odds are that maybe, a group of 10 or 12 surveyors, finger quotes, surveyors with all their cool fucking gadgets, lenses, instrumentation are going to make it 500 miles across desert and highland without running into any gangs, any pirates, any criminals, any thieves, any thugs? No, none of that. they're just gonna la la la. We're measuring our way, and everybody's just gonna leave them alone and not knock them off and take their shit when the sun goes down.
To a degree of accuracy and specificity by which is then used as a barometer to measure the whole world. Don't forget that part.
And what the heck were they using a theodolite? How are they? What do you mean surveying? I mean, come on, give me a break. Where's
Yeah.
this guy got
They were
got a
using
sun
They
out
had
there?
gnomons, I think they call it. They're just sticks they put in the ground, and they measured sun angles everywhere.
Ridiculous.
Nothing against the sun angles they measured, just the retarded interpretation of what those sun angles meant with never been observed parallel light rays and nonsense heliocentric distances. That's my only contention.
Mr.
That's
Xavier.
it. That's your only contention.
I have a couple
Just
more
the core of it.
Just the core
Like
of
how
his
the fuck
belief.
did he contact?
just like fundamentally, like where you're starting from, like I have a problem
With
with
everything you are and where you've ever been and everything you've ever done. It's all wrapped up. That's just the only thing I don't like. Okay.
like
How
everything
did
you
they
stand for.
correspond? Yeah, but how do they even correspond the angle of the wells, right? Like, hey, I'm at this well. Where are you at? Oh, I'm at this well. Like, how the
Well,
fuck did they talk to each other 500 miles or 500 stadia away from each other?
so they did it at an equinox, right? So they know the significance of that. So he's like, hey, why is it not totally at the bottom? Why is it? Oh, you know what it is? The whole world is tilted at an angle that would make this measurement work for the thing that I'm trying to do. So we'll just sideways assume that, and then we'll plug in this definitely measured distance of 800 kilometers, measured by, the second prevailing theory of why when it wasn't Bemotsis, which are professional surveyors of ancient. It must have been lab assistants, right? They just did some like interns. They just had them go measure it, and that's obviously how Eratosthenes did it. I heard a PhD in like modern science explain this. That they were nonchalantly like laughing about it because the answer is nobody knows and it's nonsense.
It's just a story.
Just a myth, dude. That's what it is. It's actually a heliocentric myth. And like the myth of dinosaurs and evolution, the myths concurrently prove each other, right? So the only evidence of one myth is this other myth that we have going on. Like dinosaurs definitely existed because of the myth of planet-ending meteors, which definitely existed, which is perpetuating the myth of evolution because Earth is actually 13 billion years old and came from the myth of accretion, which is, mass attracting myths of mass attracting mass in space so that things form into spheres that then orbit each other based on the universal law of gravitation. What's up, Xavier?
Yeah. So, to all your points, especially Stone's, something resonated when he said that there is an advantage to talking about these experiments that it has been done for hundreds of years, right, or thousands of years. To Stone's points, from the empirical observations and measurements that many of us can replicate, they want to move it to compartmentalized studies that have restricted access to quote unquote experts, right? I was just thinking about the debate that Alan had with Astronomy Live, where he sneakily begged the question. He understood since aberrations are velocity dependent, the Hubble telescope, right? That's been sent up in a thermodynamics violation area called space, disproves the results by Earth frame lab frame Aries. So I thought that was clever, bringing it to something that many of us can replicate. Not all of us can get a telescope, but many of us can, to compartmentalized, quote unquote, scientism. So something to think about.
Go ahead,
So in
Orwell.
other words, we're going to keep talking about this Orwellian. Sorry.
No, you guys can keep talking about it. I'm sort of going to change the subject, but not really, because I just wanted to ask Shane a question. It's been a while. Shane, did you ever get any pushback about that debate you had on the, God, what was it? The Verrazano Narrows Bridge that you had that debate on? Fucking, God, probably 6 months ago.
No, I destroyed him, and all the comments on the Glober side were embarrassed for the guy. It was a terrible argument. I used everything you said. It was beautiful. Even the Globers were like, somebody researched about bridges, and somebody doesn't know shit. I was like, that's fair. Thank you, Orwellian.
Right. No, I never followed up with you, and I was like, I wonder if you got any pushback on that.
No, dude, he just said tis curved, and I was like, nah. Here's 7 reasons why it's not, or it could be other reasonable stuff where you take into account, chamfer, weight, distribution, seasons, density changes. You got to be tight. Things that have weight, like, it's crazy, and it's like, oh, all that makes logic sense. And it's like, yeah, that's what a builder told me.
That's kind of what we do for a living. So it's ironic that you want to argue it and invoke fucking curvature. Cute.
I think,
But,
I think
It's
he was
so
like, I have
simple,
no
man.
measurements and I don't know how. I just think it does. That was his actual. I think he illustrated it on paint for 10 minutes. I'm sorry. Now it's coming back to me.
It's the same principle as the flatbed trucks. You can't just sit there and put a bunch of weight on there. It would buckle.
yeah, no, yeah, it's
Exactly.
weird when you see those things without a load on them, and they have like a very pronounced parabolic arc, and then you throw, I don't know, 80,000 pounds on it, and it flattens out. It was engineered for that purpose. But somehow these idiots can't apply the same logic and principle to fucking bridges. No, bridges are mystical and magical, and the longer they are, the more they account for the curvature of the Earth.
And the funny thing about it is they have to build this bridge to account for the curvature of the Earth to make the bridge curved, but the water underneath it is always flat.
Well, no, their direct argument was, hey, these 2 towers that lead to this bridge are actually, not perfectly parallel. They're tilted away from each other, and the difference is like 1.2 inches. That was the argument, and it's like, okay,
And
do you know what else can account for
reason.
that? Like, so many things, so many real world, actual physical things that people who deal with this have to account for. And it's like, all right, that argument gets destroyed.
No,
Yeah,
the bigger destruction of that argument is the secondary question. Hey, do you also realize that the longitudinal sway of those pieces of the bridge at that height are probably closer to 20 inches? Just in a comfortable wind? You know what I mean? That bridge is already moving so much more than 1.5 inches in all directions at the top of the bridge because of changes in tensile influence of the load changing constantly and wind direction and intensity changing constantly. It can even set up oscillations. That the top of that bridge is going to be swinging back and forth through 20 inches of space, say, a rough figure. It just blows away this 1.2-inch thing. It makes it completely numerically insignificant to assert such a value. You know what I'm saying?
Mathematically retarded, I think I called it.
Yeah, no, actually, I think that's a pretty accurate description. You've got, your live load is just the shit that's moving around on the bridge. Your static load is like all of the other environmental forces that are acting upon it while it's under live load. And yeah, there's all that shit's accounted for. Yeah,
using those terms.
I just wanted to follow up with you on that real quick, and we can get back to the shit that irritates me. But yeah, I was wondering, man. I was like, fuck, I never fucking asked him how that went. I knew you destroyed him, but I was just like, did he get any pushback?
No,
and I didn't think you would. There might be 2 idiots that are in my comments frequently that know I build bridges for a living that are like, Shane's an idiot or something stupid, but whatever.
Hey, I think I understand this, but just I'm sorry to jump in and change the topic. Does anyone have anything to respond to that? I was just going to ask, and I kind of think I understand, but essentially celestial theodolite takes out refraction because it's an actual mountain blocking the actual light from the star. Is that logic tracking there? Or?
Yeah, so the logic is that a refracted image isn't going to block starlight. So we're only concerned with the time when we can't see the star, and we draw our geometric implications from that.
And where can I buy one of these celestial theodolites?
Amazon.com/selltheo. Promo code SpaceAudits for 15% off.
15% off. That's a deal, man.
Dude, I couldn't believe that in the debate. I think it was McToon and you and Shane, and it was like, bro, listen to what I'm saying. You don't get what I'm trying to tell you. He's like, what kind of theodolite are you using?
And the thing with that is it was using flat Earth measurements too, and they matched it. They couldn't match them up with the globe.
the thing about that is it's mutually exclusive, and it specifically excludes the globe each and every time we match up one of them times with a flat Earth prediction.
Well, there's that one time though where it was in between, so you got to throw everything else away, right?
Hey, if I do a measurement of like a mountain from 30 feet from me and I can't tell either way because it's just a straight fucking line, then I can invalidate the whole project, I think, right?
And we'll just focus on that one measurement and never look at any of the other data.
Well, that's what
Although,
we
No
got
one
Jonathan up
actually
here.
did that.
Yeah, what's going
kidding.
downtown, Mr. Brown?
You there,
I just heard
Jonathan?
about the theodolite on sale. I've been wanting to buy one of those. So you
Are you-
said
are
that's
Are you familiar
Amazon.com
with this?
/buy Theo, what was it?
Yeah. Are you familiar with this this observation here with the mountain and the star? Dr. Heffron?
Not really.
Would
Oh,
you like to go over it there, anybody?
Alan?
I think B said he wanted to do it.
No.
yeah,
no,
yeah, I heard Peter
I heard
said.
you want to do it.
Peter's too baked.
I'm way too baked, dude.
Well, then, I'm sure Shane's not baked, right? Or Alan? I'm pretty sure.
No. We're all pretty. That's not a safe assumption to assume sobriety.
I'll do a retard edition.
I got you,
guys
bro.
can correct me.
I got you. I'll do it on the way out. I'm gonna wrap up here and for the night, but I'll do it on the way out. All right. So who am I speaking to? Is that Jonathan?
This is Mr. Jonathan Brown.
Hola, John.
Jonathan Brown.
So let's say we have a mountain peak somewhere off in the distance, John. Right, we're X distance away from it, right? And we know our distance because we can look up, our phone, location finder, etc., kind of thing. So we can get our coordinates. We know our distance and we know what peak we're looking at. We can calculate, via Haversine or whatever you want, the exact distance from us to that mountain peak, and using all the official numbers given to us by like Wikipedia, for example. So like, for example, if the pike was Pike's Peak, or if the mountain was Pike's Peak, for example, and you were, 50 kilometers away, right? You could do a little plain trig there to get what the value would be of that mountain peak relative to your distance away from it based off of, plain trig. And then you could also subtract 8 inches per mile squared off of that 50 kilometers away. So you could get what the globe Earth prediction would be. So you would have two separate calculations, two separate predictions, one based off of plain trig, one also based off of plain trig, but subtracting the difference for the globe so that you could get what the physical elevations are for those mountains. Now, as you get further away, right, the globe's going to predict that the mountain peak's going to be physically lower than whatever the flat Earth would predict, because the flat Earth, is going to be Euclidean geometry. It's always going to be at that elevation, no matter how you perceive it. Right. Whereas the globe would predict that it's physically going to be lower, and that the visual perception of it being smaller in the horizon, et cetera, isn't just like optical compression. This is a physical effect of it being tilted away from you. So what we can do now that we have our two different distances for the elevation predictions relative to our distance is we could hop into Stellarium, right? And we can use the angle that we calculated for the difference in elevation between us and the mountain peak, right? So we could take that angle now, we can go into Stellarium, we could go on top of that mountain peak. We can line our crosshair up at that same relative angle that we calculated. And then we could play out the night sky and we could watch stars until they intersect with the crosshair at that exact angle. When we get said stars, we write those stars down, and then we wait until, that night rolls around at that time, and we record the stars as they go down into the horizon, right? And we write down the time when we can no longer see them, because that means they've been occluded by the mountain peak, right? And we could correspond that angle to the time in which it was occluded, and we can determine what the physical elevation of that peak is. Like, is it actually 200 feet higher than what the globe would predict because it's actually, planar geometry for the ground, but optically we see it a little compressed? Or is it actually physically at a different elevation angle? Because the star isn't going to be occluded by an object that's not there, right? So this is going to give us two different timings. And so based on distance and based on the rotation rate of the sky, we can differentiate between the two models because, what is it? 1 arc second corresponds to 1 real second, or
No, 1 arc minute. Right.
1 arc minute is 4 real
4
seconds.
seconds.
Yeah. Okay. Yeah.
Yep.
Let's do that. It's easier. So 1 arc minute is 4 real life seconds. So as the angle that we measure that it gets occluded increases or decreases, we could correspond to that real world timing difference. And so from that, we can deduce, if the star got occluded at a time that corresponds to what would create a flat Earth angle, or what would create an angle that corresponds to the globe because it had to get lower in the horizon because the mountain's physically lower. So there's a whole bunch of, we've got a whole bunch of videos on that. I can link you a spreadsheet with some trig on it. I know you're a trig lad, so you'll probably pick it up fairly quickly, but that's the significance of it. So we had a lad who's taking different measurements of different mountain peaks, so different distances, but same location, because he's doing it all from his house, because he's surrounded by mountains. But anyway, so we have different distances, right, that correspond to times that only show a geometric relationship, where like the flat Earth prediction is what would have caused the occlusion timing, because it's much earlier than what the globe would predict. The globe predicts a later time because it has to get lower in the horizon. And I want to add something to this before I forget the significance of it. So the real important part of this too, right, is we're not just using the raw plane trig calculation prediction for the globe and the flat Earth. We're using the recorded geometric position of the star. So wherever they say the star is with no refraction on, they're referencing it. It falls back to where it would be like in the nautical almanac, like with its quote unquote true position. So we're only referencing that. We don't care about the apparent position, the refracted image, anything like that. We're drawing our relationship with the so-called true position of it. And when that includes with a mountain, miraculously, the star is no longer visible.
And so if the Earth is flat, it would occlude it sooner than expected, right?
It would occlude it later because the star has to get lower.
And in all 37 observations, that is indeed the case, and the timing matches the flat Earth and never the globe, with complete consistency with mutual exclusivity.
Yep.
The final experiment.
Now that's a final experiment. If there
What
ever was.
what I really like about it is I was just reading about celestial navigation and stuff and astronomy, and the big point about celestial navigation and astronomy is that they're dealing with the apparent positions of the bodies to make their model work, to make their conceptualization work, to relate the geography of to relate the sky to the ground, to create that geographic relationship between positions of the stars at a specific time to the ground. And none of those models deal with the actual true geometric position of it. It's always the apparent. For the first time that I'm aware of, we're actually using the so-called true positions of the bodies to substantiate, the verification of our model, which is miraculously coming out flat every time. So I'll link you those the spreadsheets and stuff. You can take a gander at it.
Yeah, that's interesting. Because even if you do account for some kind of a basic dry air refraction, you would, I think you would see a difference even with that. Because if I'm assuming that the celestial sphere above is rotating at a constant rate, then if it is curved, then it should stay in the sky longer. And so that's where I was a little confused a second ago when I asked if it is occluding sooner, because if the mountain is on a plane, if I'm using plain trig, like you said, then my mountain peak is probably up higher in my sky. And then if I have curvature that would cause it to drop, now my obstruction is probably lower in my vision.
Right.
Am I right?
That's exactly the premise.
Yep. You got it.
Okay. With or without refraction, which is what's kind of nice about it.
Yeah.
So then the conclusion that the results they're getting is that the star is
It's
what I
getting
would expect
occluded
it to be
early.
a
It's
flat
getting
Earth proof
occluded
is that
sooner.
it's being occluded sooner than expected.
It is. That is what's happening.
That's what's happening. Oh, okay.
Expected for a globe. Like, it's not really about an expectation. It's about just like, hey, let's see when this star gets occluded.
No, it's exactly about the expectation. One will
And a
be
prediction.
sooner than the other.
There's a mathematical prediction incorporating, the globe parameters, refraction, and just flat Earth plane trig. And
But yeah, that's what's dope about it.
plane.
What we found so far, John, is that so what the main like quote unquote refutation to it is right now, and it's not even a refutation. It's a completely different hypothesis. Is that at certain distances, when you add celestial refraction, you can make the apparent position line up with the flat Earth geometric position, which is like, a cool story. But what we learned from that, which turned out to be way more interesting, because the celestial refraction, so-called corrections that you apply only work with respect to an angle that is derived from a flat baseline. If you try to use the globe angle, it makes the wrong prediction. It's off by a couple arc minutes. And we know that the globe is accurate way down to the arc minute, like easily. So that can't be.
Okay, I'm actually drawing I'm overlaying a curved world onto a flat world with the same observer here on my fridge. And so the mountain goes up, a couple miles. The atmosphere continues on up above that. So the only thing I can figure is that your mountain would be lower due to some baseline refraction. Let's see, is that true? No, it'd be higher. It would be higher because things tend to curve downward to your eye. Just like in a swimming pool, you see the line of sight takes a sharp turn downward.
Yeah. So the important
the
thing,
idea.
So the important thing to remember, though, right, is that you're looking through the same optical corridor. So refracted or not, that's fine. What's important is when the star is no longer visible. That's when it's not being refracted anymore. That's when there's been a geometric occlusion somewhere that has occurred that has made it no longer visible.
Which, again, the amount would be higher on a flat Earth, right? Because it's not bending away, so that star occlusion should occur earlier.
Gives the timing difference.
Timing difference, yep.
Guilty or not guilty, right, Shane?
Hey, Alan, has anyone on the globe side provided their own occlusion timings yet, or?
So Jesse told me that if you use a different elevation for Blodgett Peak, one of the measurements matches closer to the globe. So if you use a different elevation than like the Wikipedia one, I guess that one.
Wow.
So this even counters kind of the idea that the star should hang out in the sky a little, like a tiny bit longer because of refraction. Because
yes,
yeah. So your little every arc minute, it goes a certain amount across the sky constantly until it starts to approach the horizon, and then that little bit of angular change starts to shorten ever so slightly due to that refraction of going through that much more air. And so it should even be longer, but if it's shorter, then that's even going against that.
Would you guys grasp that?
I didn't explain it very well. In other words, it's even more surprising if the star occludes sooner, given the fact that refraction, you would expect it to hang out even longer, and that's not even to speak of the dip in the mountain due to curvature. Like there's two things that are supposed to make it last longer in the sky. One is the mountain being lower, your obstruction is farther from reach for that star, and the supposed refraction is causing it to slow down slightly. And so
this is some pretty good flat Earth proof or evidence.
It's sounding like it.
That's why we love you, Jonathan. We appreciate you looking at this and not freaking out like a lot of these other guys.
Yo, John, if you click on that Google Doc, or I put a spreadsheet up in the Jumbo, if you click on it, there's another tab at the bottom called Star Measurements. So this is the full catalog that of the 37 stars that have been recorded and included. And then so what Mike realized is that if you just look at the angle relationship as things get lower in the horizon and whatnot, and just based on distances as well, sometimes the angle relationship can be a little ambiguous between the two models. But what you can do is you could derive, like once you have the occlusion timing, you could backwards derive the physical elevation based off of that timing, like what it would be to have caused it. And with that, he shows like the columns go through and it shows like what the globe says for the official peak altitudes for the different peaks, just using like the Wikipedia values essentially. And then what the trig shows the elevation is to produce that occlusion timing. And it's always more than what the globe officially says. And then on the column to the right of the flat Earth difference, there's the globe, like how much should be missing in curve. And then to the right of that is the difference between the two, which is just, adding up the flat Earth difference and the globe difference. And so like you can see the timings, like, and like what that would correspond to in elevation in feet. And it's just like, it's not even close.
Yeah, I heard Peter the other week talking to you guys about that, and I didn't really, nothing clicked on either side, frankly, and I was like, what is this new thing they're talking about? And but now I think I understand what you guys are arguing. And
yeah, if you listen to Peter, you're not going to learn much. Did you guys notice how he came in? I let him get up on the speaker stage, and he didn't say anything. Usually he chimes in like right away. I thought that was interesting. He doesn't want any smoke.
I mean, shout out to Peter, dude. He made an Ether Cause contribution and bought a t-shirt and a hat. Shout out to your boy.
He's got a new episode of As the Globe Spins Out.
He's trying to get back into Ether Cause, man. He's hoping that I bought the hoodie, man. Let me in. Unblock me.
Yeah. He asked about getting unbanned. I was like, it doesn't work that way, dog.
But thanks for the purchase. Have a nice day.
Yo, shout out to Jonathan for grabbing a mic and Uvalde. I mean, it's hard to get the Globies on stage these days, and you guys had some good conversations, so I appreciate it.
Well, at least Jonathan said, well, that is interesting. I'm going to have to consider looking at it a little deeper. Uvalde said we brought nothing.
Yeah, I gave Uvalde a little too much credit. I like how Stone pointed out He kept saying, we've done it, we've done this, we've done that, and we're like, okay, show us. Or everything points to the globe. Everything. It's like, okay, name one thing. Dude, I can't tell you how many times I've run into that. Yeah,
Pictures of the globe.
Just hold their feet over the fire and like, okay, how does orbital mechanics work on a globe? And like 99.9% out of 100 times, they have no clue at all. Like they just know somebody else did it. Not to be
it is known.
It is
prophecy
known.
Foretold.
There it is. It is known. Dude pulled out Game of Thrones on your ass.
You gotta sometimes.
Like, do you think how much time do you think you spent looking into the claim gravity forms balls, right? I mean, I'm sure it's something he heard sometime somewhere, but
he's never looked into it. He just came up with that whole idea. He's never looked into it. Gravity forms balls. Give me a break.
It was like gravity form ball, but like the whole anyway, he's a good lab, man. Forget about it. Anyway, I'm gonna head off
Yeah,
for the
I'm
night,
sorry, guys.
lads. You guys have a good weekend. Tune in on Monday for the celestial theodolite update. We'll be talking about these refractions, these quote unquote celestial refraction corrections that are implemented for celestial navigation and Solarian, etc. We'll get into that. And then Tuesday, I'll be doing a presentation on the deconstruction of the globe model and flat earth model and rhetoric and stuff like that. So we'll be getting into that on Tuesday. And these will be done at 8 p.m. Eastern, boys. Then Thursday, the return of research and reading night will prevail. We'll read us a paper or two. And then Friday, we'll be back to discuss what we learned throughout the week with the boys and disseminate the information.
Peer-reviewed papers, Alan?
Yep, I reviewed it. He wrote it. That's how it works.
Yeah,
That's how it works.
Peer
Needs to be
reviewed
speared,
by
that's
me.
right. You got it.
I can't
Yes.
believe people believe in peer review. It's like, really?
Same here. It's after midnight here, so we'll be making our exit.
Yep, I'm going.
Yeah.
I'm tired.
But it's been a blast, man. As
Well,
usual.
thanks for stopping in, man. Shout out to Ether Cos, man.
It's always super fun. Thanks for hosting all day like a trooper, dude.
Yeah, I'm probably going to be hanging it up. I think my co-host is asleep.
And
Which
just ask
one?
him a Globy question. Oh,
All right, boys. You guys heard the schedule for the lineup. If anyone wants to join us on Discord and hang out, play code names throughout the week, we usually do so after Ether Cause events. So here's a link to the Discord. See you guys on Monday.